Good evening, everyone. On behalf of Deccan Education Society, Institute of Management Development and Research, Pune, I, Dr. Gopa Das, extend a very warm welcome to you all for this 6-day ATAL online FDP program on next-gen communication, technologies and application. We are honored to host participants from across the country, and it's truly heartening to see such enthusiastic educators, professionals, and PG and research scholars coming together to explore the future of communication technologies. I also take this opportunity to welcome our director, Dr. Shikha Jain, my fellow co-coordinator, Dr. Pritha Ubgade, our technical support head, Mr. Kiran Kadam, our distinguished resource persons, and of course, all of you participants who form the very spirit of this FDP. As we all know, communication is undergoing a massive transformation. From the days of telegrams and landlines, we now talk about 5G and 6G networks, artificial intelligence powered communication systems, IoT enabled smart cities, and cybersecurity safeguarding our digital lives. Communication is no longer just about transmitting information. It's about speed, intelligence, connectivity, and trust. For instance, picture this. Imagine a surgeon in Pune performing a critical operation on a patient in New York in real time. Now, that's the power of low latency 5G and 6G. Or maybe think about AI chatbots handling millions of customer queries simultaneously. And that's AI driven communication at work. And of course, when we talk about smart homes and smart cities, it is the IoT and cloud computing making it all possible. This FDP is designed to take us on a journey into these exciting areas where technology meets business, society, and education. This FDP is a part of ATAL Academy initiative of AICTE, which is instrumental in nurturing faculty development across emerging areas of science, technology, and management. The ATAL FDPs are unique because they bring together academia, industry experts, and practitioners on one platform, ensuring that the learning is practical, relevant, and forward looking. At IMDR Pune, we have always believed in staying ahead of the curve, blending management education with contemporary technological advancements. This FDP is another step in our commitment to preparing both faculty and students for the future of communication in a digital first world. Now, to formally inaugurate this FDP, it's my privilege to invite Dr. Shikha Jain, Director IMDR, who has been a constant source of inspiration and guidance. Ma'am, we look forward to your words of wisdom and encouragement as we begin the 6 days journey. Over to you, ma'am.
Thank you so much, Gopa. Can you hear me? Am I
Yes, ma'am.
audible?
Yes, ma'am.
So good evening, everyone. On behalf of the Deccan Education Society, its Institute of Management Development and Research, Pune, it is my privilege to welcome you all to the ATAL Faculty Development Program on Next Generation Communication Technologies and Applications. A very special welcome to our distinguished international resource persons who will bring with them not only expertise but also perspectives from across the border. Their presence enriches this program, and we are truly honored to have all of them with us through the 6-day journey. I also warmly welcome our participants, faculty members, researchers, and professionals from across India who have taken time to invest in their growth and through that in the growth of their students and institutions. I must also acknowledge, as my colleague Dr. Gopa mentioned, the ATAL Academy for its pioneering work in reimagining faculty development. It is not just about upgrading skills, it is about preparing educators to equip the next generation of leaders. And in that journey, this FDP on communication technologies is both timely as well as significant. So why is the theme of next generation communication so crucial today? Because communication is not just about words, it is about connections. It is about how we reach people, how we share knowledge, how we build trust, and how we enable action. In management, communication is the heartbeat of leadership. In technology, it is the invisible network that powers innovation. When the two come together, communication and technology, they have the power to reshape industries, societies, and even governance. Let me start with some simple, relatable examples. Think of Swiggy or Zomato. A small restaurant in a neighborhood can now reach thousands of customers daily because communication technologies like GPS, real time tracking, AI driven recommendations enable seamless interactions between customers, restaurant, and delivery partner. This is not just food delivery, it is micro entrepreneurship at scale. Think of e commerce platforms like Flipkart and Amazon. Sellers from small towns in India who once had no reach beyond local markets are now sending products across the world. Why? Because next generation communication technologies, IoT enabled warehouses, AI powered recommendations, and 24 cross 7 chat support have flattened barriers. Or consider education during pandemic. A village school teacher could continue classes through video conferencing. A fitness trainer could teach yoga across continents. A homemaker could start an online bakery and scale it into a brand. All of this was made possible because communication technology has become a great equalizer. But let's also look at larger national examples. The rollout of 5G by Reliance Jio is one of the fastest in the world. It is not just about faster streaming or smoother video calls. It is about enabling remote healthcare, as Gopa mentioned, where a specialist in a metro city can examine patients in a rural village through high definition images or even guide robotic surgeries in real time. It is about education. Students in uh, underserved regions accessing immersive AR-enabled classrooms. It is about industries adopting IoT at scale to make operations smarter. Another example is the ONDC, the Open Network for Digital Commerce. This government initiative is a communication protocol for commerce itself. It allows buyers and sellers to connect without being restricted to one platform. For a viewer in Jaipur, this means her products can be discovered by a global audience without paying high commissions to large e commerce giants. This is entrepreneurship at its most inclusive, removing barriers, empowering artisans, and building fair competition. In agri-tech, the story is equally powerful. Startups are using IoT sensors to monitor soil health, drones for precision spraying, and AI driven apps to provide farmers with real time market prices. Imagine the communication chain. Sensors feed data to the cloud, analytics convert it into insights, and those insights reach a farmer's smartphone in seconds. For the farmer, this is not abstract technology. It means higher yields, better income, and reduced risk. The government of India also has taken some visionary steps to harness next generation communication for governance, development, and inclusion. Digital India Mission, launched in 2015, has transformed the way government connects with citizens. Platforms like DigiLocker for document storage, Umang for accessing government services, and Aadhaar enabled direct benefit transfer are all built on secure communication frameworks. Citizens no longer need to stand in queues. Governance now comes directly to their smartphones. BharatNet project is the world's largest rural broadband project, connecting over 250,000 gram panchayats through optical fiber. It is not just about internet access. It is about giving every village a voice, enabling e-health, e-education, and e-governance at grassroots level. Aadhaar is the world's largest biometric based identification system. It is fundamentally a communication system. It verifies identity across platforms in seconds, enabling financial inclusion, subsidies, and governance with speed and transparency. With IoT sensors, as Gopa mentioned, AI powered surveillance, smart traffic systems, and real time dashboards as a part of Smart City mission, Indian cities are reimagining urban governance. Citizens and administrators are now connected in ways that makes governance not only faster but also more transparent and participatory. Each of these initiatives shows us how communication technologies are not just commercial tools but governance enablers. They empower citizens, enhance transparency, and make development more inclusive. Now, what does this mean for us in a business school environment? It means that our role as educators goes beyond teaching theories of management. We must help students see the connections between technology, governance, and business. Tomorrow's leaders will not just run companies, they will build ventures that collaborate with governments, that solve social problems, and that create impact at scale. Consider some of India's startup success stories. Udan, which connects small retailers with wholesalers, streamlining B2B connections, communication. Dehat, which empowers farmers by linking them to agri advisory, inputs, and buyers, all through a mobile app. Pharmeasy, which integrates doctors, pharmacies, and patients into a single digital communication chain. These startups succeeded because they understand communication as the backbone of value creation. For us, this FDP is an opportunity to explore how next generation communication from 5G to IoT to AI can be used not just in technology labs, but in classrooms, in research, in entrepreneurship, and in governance models. At IMDR, our mission is to nurture responsible entrepreneurs and business leaders who connect ideas with practice and vision with values. This program aligns deeply with that mission. Let me close with one thought. In our Indian tradition, we speak of Vasudev Kutumbakam. The world is one family. Next generation communication is turning this ancient wisdom into a living reality. It allows a farmer in Maharashtra to access global market prices, a startup in Bangalore to raise funds from Silicon Valley, and a researcher in Pune to collaborate with peers in Europe in real time. The boundaries of geography and access are dissolving. What remains is our ability to use these tools with wisdom, responsibility, and imagination. I urge you all to use this FDP not only to learn but also to reflect. How can these technologies enrich governance, empower citizens, and inspire entrepreneurship? How can we as educators prepare our students to lead in such a world? With that, I once again extend a warm welcome to all our resource persons over the next 6 days, participants, and colleagues. May this FDP be a journey of discovery, collaboration, and inspiration. Thank you so much, and a warm welcome to you all.
Thank you so much, ma'am, for those reflective and thought provoking words. They have set the tone for our FDP and encouraged us to look forward to the sessions ahead. As we begin with this faculty development program on next gen communication, technologies, and applications, let me give you a quick overview. Over the next 6 days, we will have a total of 13 sessions carefully designed and delivered by a mix of eminent national and international speakers. These sessions will cover a wide spectrum of next generation communication technologies, combining theory with practical insights. On the last day, we will have an online test and overall feedback session, which will be essential for earning your certificate. Along with this day, daily feedback will also be taken to ensure the program remains interactive and meaningful. Please note, dear participants, that 80% attendance with minimum of 70% marks in the online test are mandatory for you to qualify your certificate. The daily meeting links will be shared with you in the dedicated WhatsApp group for your convenience. And we encourage all participants to stay engaged throughout, making the most of the learning and actively share questions or thoughts in the chat box during the sessions. Before we move ahead, let's do a quick reflection together. I would like all the participants to think about this. Do you believe India will leapfrog into 6G before the world does? And if that is a yes, drop a quick yes in the chat box.
I think, Gopa, a lot of participants have reacted with a yes. So
I think we all believe that this is going to be the next tomorrow. Well, thank you. Let's take another one. Which one excites you more? Choose the option between A or B. Option A is AI powered communication networks, or option number B could be IoT driven smart cities. You may choose your option and share your choice in the chat box. When we see a mixed reaction, some of you have mentioned A, while some of you are mentioning B, and there is a certain section which is mentioning both.
I can see a
Well,
lot of A's if you compare. So that is the option, I guess.
all right. So this is just to spark your curiosity, because in the coming session, we will actually dive deeper into these areas with our experts. So before we begin with our technical sessions, we would like to take a quick pre-assessment exercise. This is a short activity which will help us understand the diverse knowledge levels that each one of you brings to the program. Please don't consider it as a test, but rather a way to capture a starting snapshot of your perspective and awareness. So, at the end of the FDP, we will revisit a similar exercise, and together we will be able to see the progress, the new insights, and the fresh learnings that have emerged over the 6 days. We are sharing the link in the chat box. Request you to kindly take few minutes to complete it.
I have shared the links in the chat box. I'll request all the participants to please fill up the Google form.
We hope you are finding the link accessible.
In case of any queries related to link, please you can put the queries in the chat box. I think many participants are looking for WhatsApp group. It's pasted in the chat box link of the Teams meeting. So you just have to click on the chat button, which is there on the Teams website, so you can access. I have pasted the link again.
Pratha ma'am, can you see any responses who have submitted their reactions?
Not yet. I'm unable to see. I think everyone is taking up the questionnaire. For the ease, I'll also paste the link on the WhatsApp group also. I hope everybody got the link for the pre-assessment questionnaire. Everyone has started filling the responses. For now, I have received 9 responses. I'll request everyone to please fill up the Google form, which has been shared with you all. It is there on the WhatsApp group as well as the chat box of the Teams meeting. So I can see around 227 participants, and out of which so far I have received 32 responses. I'll request everyone to please fill up the questionnaire. I've received few notification. Participants are submitting the Google form. So far I have received 55 responses. Um, I hope everybody's okay. I mean, in case of any queries, again, I'll repeat. The link has been pasted on the WhatsApp chat group as well as there in the chat box of the Teams meeting. So far, I have received 71 responses, and I can see there are 230 participants in the group. I'll request all the everyone to please fill up the pre-assessment questionnaire. For now, I can see 92 responses. So I'll request all the participants to um, please fill up the pre-assessment questionnaire. On the WhatsApp group, I can see one of the chat. Please understand, four fields such as name, designation, and all, the score is included over there. Please believe when we will submit, we'll remove those score and you will be evaluated for the questions which you have appeared for. So I think that is the
Ma'am, with
basic
your
information.
permission, can we begin with the session?
Yes, ma'am. I think we have received enough responses. The link is open for another 10-15 minutes, but I think we can proceed further with our next session. And this link
All
is
right.
open for another 10 minutes. I'll request all the participants to please fill up the Google form. Over to you, Gopa, ma'am.
So thank you, Dr. Pritha, and thank you all for completing the pre-assessment. With that, we are all set to begin our technical sessions. Our first session today is one of the most exciting and transformative topics of our time, 5G and 6G technologies. And it's my great honor to introduce our distinguished speaker, Mr. Yogesh Dubey. Mr. Yogesh Dubey is a seasoned telecom and ICT professional with over 23 years of experience in designing and delivering innovative enterprise communication solutions. He currently serves as a domain expert in solution engineering at Tata Teleservices Pune. He specializes in next gen communications, cloud solutions, and enterprise networking, supporting industry specific solutions such as MPLS, SD-WAN, IoT, SaaS, cybersecurity, and many other multi cloud solutions. Before joining Tata Teleservices in 2012, Mr. Dubey held key roles at Aegis Limited, SR, and Cisco. He has led high impact projects including the Microsoft Team Operator Connect launch in India, large scale WiMAX rollouts, and global unified communication implementations. Throughout his career, Mr. Dubey has driven strategic product development, proof of concept initiatives, and capability building programs. He holds a bachelor's degree in electronics and telecommunication engineering and is certified in PMP, ITIL, Cisco certifications such as CCNP and CCNA, AWS Solutions Architect, and Microsoft Azure Solutions Architect. His work focuses on bridging cutting edge technologies with real world business applications, making his insights highly relevant in today's rapidly evolving communication landscape. We are truly delighted to have him with us today to share his expertise and perspective. Let us all welcome Mr. Dubey, who will enlighten us today on the fascinating world of 5G and 6G technologies. But before I pass on the mic to Sir, dear participant, kindly note that due to the technical control settings, participants' microphones and cameras will remain disabled during the session. If you have any questions for the speakers, kindly post them in the chat box. This will be taken up at the end of each speaker's session. Yogesh sir, the forum is all yours now.
So, hi everyone, very good evening to all of you. Hope I am audible and visible to everyone. Let me share my screen.
Yes, sir, you're audible.
Okay, so can you just confirm whether you can see my screen or not?
Yes, sir, your screen is visible.
Okay, great. So I would like to say thanks to Dr. Gopa and Dr. Pitha for the kind introduction. And I am privileged and honored to be part of this webinar. Also, I would like to say thanks to Dr. Sikha Jain and the team IMDR for the invitation and to be part of this webinar. Okay. So today I'm going to talk about next generation communication technologies. Okay. And this is kind of coincidence that we have joined through this tool called Microsoft Teams. Okay. So this tool is called a collaboration tool, and wherein we can have audio, video, and web conferencing. And you can just imagine 20 years, 25 years ago. So there were no such tools available. So audio conferencing was a separate tool, video conferencing was a separate tool, and web conferencing was a separate tool. But over the period of time, technology got evolved and all these three platforms came together and this type of tool got developed. Okay. So there are many organizations who are offering this type of tools, mainly this Microsoft Teams, Ring Central, Zoom video communication, Cisco WebEx, and even there are small players who are available and who are offering such tools in a very cost effective and customized solution to SME and micro SME segments. Okay. And but what about the business impact? Okay. So nowadays enterprises are adopting such tools and they are saving a huge cost for their organizations, which includes the travel cost. It's whether it's local conveyance or domestic travels or international travels, along with the hotel and stay cost, food cost, and so on and so forth. Okay. Second thing is that it gives us the flexibility. So wherever we are, whenever we want, we can just join with this tool and we can have the conversation. Okay. The typical use case of this tool is kind of online education, online learning, online training, webinar, webcast, and so on and so forth. Okay. So this is a very nice tool and it's playing a critical role in our daily life. Okay. Now this is agenda for today's call. So I will talk about evolution of telephony, evolution of mobile communications. Also, I will talk about the components of 4G, 5G, and 6G technologies, along with the satellite communication, Internet of Things, followed by some industry use cases. Okay. Oh, I think you are surprised. So I am talking about next generation communication technology, and I am showing you a picture of cows. But there is a reason behind. Okay. So let me use pen. Okay. So the name of this cow is Mansi, and the name of this cow is Nandini. Okay. So when Mansi went in front of the feeder machine, so feeder machine denied to offer feed to Mansi. While Nandini went in front of the feeder machine offered feed to the Nandini. So what is the problem between this feeder machine and the Mansi? So you can just think and you can just put your comment in chat window. Okay, so we'll talk later in this matter. Here I can see a photo of a operation theater. There is a patient, there is robots, but I cannot see doctor. So I believe this patient is also surprised. Where is my doctor, and how my procedure will be done? So let's find out what happened with this patient. We'll discuss. Okay. So here I will talk about the evolution of telephony. So probably I'm sure you might know Alexander Graham Bell, who has invented telephone. And the first sentence that was used was, Mr. Watson, come here, I want to see you. So this was a kind of a lab setup wherein Graham Bell was in one room and Watson was in other room. And they were just doing a research how the voice signal can be carried over the electrical wire. So ultimately they got successful, and this is how the telephone got invented. Okay. And the first telephone exchange came into picture in 1900. Okay, and the name was this. The name was this telephone exchange is Stauger Exchange, and it was a completely mechanical exchange. Okay, so it requires a huge space to install, so around 200 to 300 square feet area. Okay, probably I'm not sure whether you have seen this kind of exchange or not, but yes, I have seen this exchange when I was working in Southeastern Central Railway project, and the project was to replace this Stauger exchange with the electronic exchange. Okay. And about analog telephony, so probably you can just recall your BSNL home phone days. So that was part of analog telephony. Nowadays, whatever the phone you can see in your organizations or in your meeting room, so that are the digital phones, or that are the IP phones. And the best part of digital technology is that you can get a better audio quality or voice quality as compared with the analog telephony. Okay. Then the ISDN services evolved, and this is the first services which allowed us to access internet by using the telephone lines. So you can just recall the dial-up modem days. Okay, so ISDN stands for Integrated Service Digital Network, and the concept of this technology is that how a single copper cable can carry the voice signal, data signal, as well as the video signal. So that was the basic aim to develop this technology. Then the mobile technology came into picture. We'll talk about this in next slide. Nowadays, the technology which is being used are the VoIP, voice over IP, internet telephony, cloud telephony, as well as the unified communication. So nowadays, organizations are not preferring to build any kind of infrastructure at their premises. They just want to use some kind of hosted services or some kind of software as a service. So wherein they can just subscribe the service and they can use. Okay, so this Microsoft Teams is also part of this type of solutions. So there is no need to build any kind of infrastructure. Okay, so we have just subscribed to the license and we are using this tool. So this is the kind of trend I can see in the market nowadays. About the mobile communications, so yes, 1G was purely based on the analog technology, and it was for limited geography. So there were no roaming allowed, and it's a very I can say the backbone was still in the PSTN network. Okay. The 2G technology, wherein the digital voice came into picture, SMS services came into picture, but still there was no internet. Okay, so internet started in the technology when GPRS and Edge got evolved. So GPRS stands for General Packet Radio Services, and Edge stands for evolved enhanced data rates for GSM evolution. So when this technology got evolved, then we got or we allowed to access the internet in our mobile devices. Okay, but speed was very limited. It was just 144 kbps per device, and even in 3G, so the speed of internet was not drastically enhanced. It was just increased from 144 kbps to 384 kbps. And also the network was very complex in 3G technology. So for voice communication, there was a separate setup which follows the circuit switching, and for data communication or internet access, there was a separate setup which follows the packet switching. But in 4G, so we can see a drastic changes in internet speed. So here per device can get up to 10 Mbps speed. And also the latency got reduced from 150 millisecond to 10 millisecond. So because of this high speed internet and because of the low latency, so this 4G technology has supported some specific application like high definition video call, high definition audio calls, video games, and online this gaming, online streaming, video streaming. So this is how the 4G offering the services to us. In case of 5G, 5G the still we can see there is a drastic significant changes in the internet speed. So per device we can get 100 Mbps, up to 100 Mbps kind of internet speed. Okay. Also the latency got reduced from 10 millisecond to 1 millisecond. Okay. And when this development was happening in 5G, So there are three major applications that they kept in focus, right? So that was the massive machine type of communication, which is nothing but IoT services, network that enhanced mobile broadband, and ultra reliable low latency. So these three applications that is in core of 5G development. 6G technology that is under development, and they are expecting to be in launch by 2030. And there are a lot of development happening in the AI front. So they are just exploring how the AI can be used in mobile communication and in 6G technology. So that development is going on. Now, before talking about the details of network elements in 4G, 5G, or 6G technology, so it's required to understand the radio elements. Okay, so these are playing a very important role in mobile communication, and these radio elements are called radio access network or RAN services. Okay, and in RAN services there are two major components. One is called BTS, base transreceive station, and second one is called the BSC, base station controller. So base station controller is basically a brain to the BTS. So it supports it manages the multiple BTS or group of BTS, and it also manages the radio resource signaling and the mobility. And BTS has three major elements. So that is the antenna, second one is the mast, and third one is the radio equipment. So here you can see some antennas, mast, and radio equipment. So this type of antennas, okay. So this type of antenna is called in building solutions. So probably you have seen in your inside building or basement or parking spaces where the mobile signal is low. So this type of antenna generally got used to enhance the mobile signal inside the building. This type of antenna is called the microwave antenna, and this antenna is generally used for point-to-point communication or one tower to other tower communication. Okay. This antenna is called the directional antenna, or sometimes it is called a GSM antenna. So it is just transmit signal in some specific direction with some specific angles like 60 degree, 90 degree, or 120 degree, something like that. Okay. This antenna is the omnidirectional antenna which transmits signal over the 360 degree, and this antenna is generally used for broadcasting. So probably you might have seen the TV broadcasting towers or radio broadcasting towers. So this type of antenna is generally used. Nowadays, the antenna which is used is called array antenna. Okay, so here you can see small antenna cells, and this small antenna cells can be grouped together to achieve higher signal strength or to achieve cover a specific geography or to serve a basic or some specific services. Okay. So this type of array antenna is nowadays is becoming more popular. Okay. Regarding the pole, so in the terrace you have seen this type of a pole, and there is antenna, or this type of mast and there is antenna. So this type of mast you can see in urban areas. Okay. While this type of mast or pole you can see in rural area, wherein the mast can be directly erected in ground. Okay. And alongside highway also you might have seen this type of antenna. So here every BTS has this type of cabin. Okay. And here you can see the picture of this, inside of this cabin. Okay. So here there is a network rack, and in network rack there are multiple equipments installed, and there are some cables. Okay. So this equipment is called the baseband radio unit. Okay. So whenever the user traffic comes from the applications or cloud server or network using the RJ45 cable, so this signal come to this baseband unit, and this digital signal will be converted into baseband signals. Okay. So this baseband signal is basically low frequency radio signals, and but this cannot be directly transmitted over the antenna, because the frequency is very less, and frequency is just inversely proportional to the size of the antenna. So if we want to transmit this baseband signal over the antenna, so antenna size will get increased, which is not viable, business viable, or which is not a practically possible. So what we need to do, we need to just we need to have a high frequency signals. Okay, that frequency signal is called the carrier signal. So what happens? This baseband signal will be transmitted to this radio unit, and these are the radio units. Okay, and this radio will generate a carrier signals. So generally in India, 700 megahertz, 800 megahertz, 900, 1800, 1900, 2100, and 2300 megahertz, 100 megahertz frequency band is used for GSM communication, okay, or mobile communication. So this carrier frequency will be generated by this radio unit, and this baseband signal will modulated with this carrier frequency, and it will go to the antenna, and through antenna it will get transmitted to the sky or destination, okay, by using this jumper cable or antenna cables. The receiving process is just opposite of this. So antenna will receive the signal, it will come to the radio unit, wherein radio unit will just segregate the carrier signal and the baseband signal, and baseband signal will come to the baseband unit by using this common interface, right? That is called a CPRI. And from baseband unit, it will just convert it into the digital signal, and it will go to the network or application. So this is how a radio unit works. So this is applicable for all the mobile communication, whether it's a 2G, 3G, 4G, 5G, 6G. The concept is remain same. Okay. Now I will talk about the components of 4G. Okay, so here you can see, yeah, here you can see user equipment. User equipment is nothing but it's your mobile phone or your IoT devices. Okay, the radio access network ran here. This is called eNode B, evolved node B. Okay, and these are the network elements. Okay, so in 4G communication, the network elements are called EPC, evolved packet core, and evolved packet core has two components, that is called SGW and PGW. So SGW is the serving gateway, so which is responsible for building a bearer channel or PDU channel between a user equipment and this PDN gateway. PDN gateway is responsible for the integration with the external network like internet or IMS. Okay. MME, so this is a network component which stands for mobility management entity. This is basically responsible for authentication and registration of the equipment, user equipment. HSS, home subscribers system, that is nothing but a database which stores all the users profile data. PCRF is policy and charging rule function. Basically, this stores all your plans, whatever you have subscribed. So let's, for example, you have subscribed a 2 GB unlimited data call per day. So this plan will get defined here, PCRF, and it will control with the help of other network elements. Okay. IMS is basically a IP multimedia subsystem which is responsible for voice communication. So if you are making any voice call from your mobile phone, so that will route here, and here it will go to the destination. So I will talk about this. Transport network, generally this is used in mobile communications. There are three medias, right? Fiber, copper, and RF. So if the distance between two devices is less than 100 meter, so generally copper is used. If the distance is more than 100 meters, so fiber is used. And if there is a tough or difficult terrain, or there is a cost of laying fiber is high, so in that scenario we can also use the microwave antennas or RF signal to connect between to establish connectivity between two network elements. Okay. VPN and CDNs these are the application, virtual private network and content delivery network, that is generally used to suffice a specific type of services. Okay. Now here we can discuss about the call flow, how you can make a call in mobile network, or how you can access the internet. Okay, so let's, for example, this is my mobile device. Okay, and I have SIM card from Airtel. Okay, so once I power on my mobile device, so it will try to find out the Airtel BTS. So this is, for example, this is the BTS. Okay, so first it will try to find the BTS. So how it can find the BTS? So every tower or every BTS, they are broadcasting a specific signal that is called the synchronization signal, which carries some basic informations like the details about the operator, details about the network code, details about the country code, details about their location code, and and some other parameters. Okay, and also this mobile device has the SIM card. Okay, and this SIM card is preloaded with some basic information. So this mobile device will match both the configuration. If it matches, then this mobile device will get attached with this BTS. Okay. Now, once this mobile device identifies the BTS, then it will try to register with the core network. So this is the core network. Okay. So for that, this mobile device will send a registration request, and this registration request will come to the MME, because MME is responsible for registration and authentication of the equipment. Okay. But before registering, this MME will just try to authenticate this device. So what happens? This MME will just take help of HSS. Okay, this is the database wherein it will get the complete profile details of this user equipment. Now this MME will send a challenge request to this user equipment to share your complete identity. So this user equipment will share their SIM card number, their mobile number, their encryption key, authentication key, and some other information. And the MME will just match both the informations, what is received by the end user and what is received by the HSS. Okay, and if it matches, then MME will authenticate this device and it will register this device. Okay. So once this device is registered with the network, then this device can use any kind of application, whether it's a voice call or whether it's an internet access. Now, when this request will come to the MME will send a signal to serving gateway to establish a bearer channel or PDU channel between this user equipment and PDN gateway. And this PDN gateway will just check the policy or plan, whatever you have subscribed. Let's, for example, it's a 2 GB per day data limit. So it will just monitor this plan detail, and it will allow to access you the internet. Okay. So PGW is the interface to connect with the external network. And once you exceed that plan 2 GB per day unlimited calling, right? So if you exceed this plan, so this PGW will just stop this bearer channel, so that you cannot access any data after that. Okay. So this is how the complete call flow happens in 4G, and it's similar in 5G and 6G technology as well. Okay. So these are the complete function or role of each and every element. So here you can see MME is responsible for authentication, registration, mobility control, and lawful interception. So this lawful interception is used by lawful enforce agency to just track or monitor some users, okay, for some specific purpose. SGW serving gateway is responsible for establishing the bearer channel, CDR report, call detail record report, anchor point for the mobility. HSS is nothing but a database which stores the subscriber data, security key, location info, roaming management. PCRF defines the policy and plans, quality of service, and PGW is responsible for enforcement of this policy and quality of service. Okay. VoLTE, so this stands for voice over LTE, and if you have the 4G SIM card, so probably you can see in your mobile phone this terms mentioned in just near your signal tab. Okay, so VoLTE is nothing but it's a 4G technology only. Okay, and if you are making any voice call, so this technology will come into picture. So let's, for example, this user want to make a call to this user. Okay. So what happens? So the requirement or request will come to the PGW, and PGW is responsible to have the interface with the external network. So it will route request to the IMS. So the main element of IMS is the CSCF, call session control function. So this is also called a SIP proxy. SIP stands for session initiation protocol. it's a voice communication protocol, and it's responsible for establishing and terminating any voice calls. Okay. So here the requirement will come to establish a voice call. So CSCF will see where the destination is registered. So it will ask the destination serving gateway to establish a bearer channel with this user equipment. So the bearer channel will get established between these two elements. So once the signaling will get established, then the end-to-end bearer channel will get established between these two user equipment, and then the voice conversation will start. So this is how the voice communication happens in the 4G technology. Okay. Here you can see the components of 3G technology. So I have mentioned that 3G technology, there are two separate networks. So voice call will follow this circuit switching path. So these are the TDM circuits. Okay. And the data communication will follow the IP packet IP path. So here the SGSN, GGSN will come into picture, and it will route the request to the internet. And let's say, for example, if you have a 3G SIM card, so this is the 3G network, and if you have you want to make call to the user who are using 4G SIM card. So how this interoperability will be established? So for this interoperability, we need to build a inter-networking IMS. Okay. So this inter-networking IMS will establish the interoperability between 4G network and 3G network. So this is how, so you can make any call to anyone. Okay. So whether it's a 2G network or 3G network or 4G network. So there are some network elements who are establishing the interoperability. Okay. Now here the components of 4G, and it's the same analogy like your 4G. Okay, so here also you will find the user equipment. So that is nothing but your mobile phone and IoT devices. This is the RAN network. Here in 5G, RAN network is called next generation node B, next generation node B, G node B. In G node B, it is divided into two components: the centralized unit and distributed unit. So distributed unit is generally installed at the sales site, while the centralized unit is generally installed at the cloud site. So hence this is called the cloud native RAN in 5G technology. Okay. The core network component, so it's a similar kind of 4G network. So here the AMF access and mobility function is just a similar kind of MME in 4G. SMF session management function, which is similar like SGW serving gateway in 4G. UPF user plane function, that is similar like your PDN gateway in 4G. UDM is similar like your HSS in 4D, Unified Data Management Manager. So this is a kind of database. Okay. And PCF, so it's similar like your PCRF in 4G, policy and charging function. Okay. But apart from these elements, there are some advancement in 5G. So there are few network components is evolved. So that is called NSSF, network slicing selection function. So what happened in 4G? The network is divided into sub networks or small sub networks, right? And the sub networks are called slicing. And this slice is independent from each other, and they can be used for multiple service or separate services. Okay. And this selection of network slice is defined by this NSSF, network slicing selection function. So if any service want to use some specific network, so it will decide which network function can be used for this application. So that decision is taken care by NSSF. Okay. There is a NRF, network repository function. So here in 5G, there is a new concept. I can say it's a new concept that all these components are called network functions in 5G. and this network functions behave like as a service. Okay, so let's for example AMF is offering services to other network function. At the same time this AMF is using services from the other network function. So hence this complete architecture is called the service based architecture, so that one can offer the services, and at the same time one can receive the services or use the services from other network function. Okay, so this network repository function basically whenever the requirement comes, so that will go to the network repository function, and network repository function has the detail about all the network function, and it will decide which network function can be used for this application. So the requirement will be forwarded to that specific network elements or network function by NRF. NEF, network exposure function, it is responsible for the connectivity or integration with the external network by using the API. Okay. The transport network, so yes, there are three medias that is still there, fiber, copper and RF. But here in 5G also they have explored the satellite communication. Okay, so if there is no 5G signal, so you can just connect with the satellite, and you can still use your 5G services. Okay. uh, uh, Multi-access edge computing. So because the speed is very high and latency is very low, to keep this KPI or service level, so it's required that processing element is near to the cell sites. Okay, so this edge computing is helping in this regards. Okay, and also the external network function, which is responsible to connect the third party applications or external elements. Okay, and network slicing I have already discussed. So network is divided into small subnetwork, that is called slice. Call flow. So call flow is similar like your 4G network. So yes, your mobile device will get registered through AMF. Okay, and AMF is here you can see a new function, AUSF, authentication service function. Okay, since the load on AM, to reduce the load of AMF, this new function is established in 5G communication. So with the help of AUSF and UDM, the end user will be authenticated and registered to 5G core network. Okay, once the device will get registered, then it will just send a signal to SMF, session management function, to establish the PDO session between this user equipment and UPF. But here the SMF has the more work as compared to the PDN gateway or serving gateway in 4G network. So here all it will coordinate with the AMF, it will coordinate with the UDM, AUSF, PCF. All the coordination will be done through the SMF, session management function. And it will just check the policy, it will check the quality of service, it will be responsible for the IP allocations and other services it can perform. And once this all the details will come to the SMF, then it will ask a UPF to establish the packet session with the end device or with the user equipment. Okay, so here these are the separate role of each element. So here you can see SMF PDU session is IP address, traffic routing, quality of service and policy enforcement, and UPF is just responsible for routing of the packet and forwarding of the packet. So here in 5G the control elements is and network user plane is completely segregated. Okay, so the white these lines are the control plane, and this line are the user plane. Okay, so control plane is basically manages the signaling part, while the user plane is just responsible for the actual routing of the traffic. Okay, so this is how the 5G elements work in 5G network. Here you can see the service level in 5G network. So the inside this is the 4G network diagram. Oh, okay, here you can see their parameters, and the outer circle, this is the 5G service level. So if you see the service level, right, so the peak data rate in 5G network, that is defined at 20 Gbps per second. But this is just a kind of ideal scenario. So if you have a single BTS and single user, then this user can get up to 20 Gbps speed. but this is not possible in practical scenario. Okay, so yeah, or I can say this is the capacity of a BTS tower. So this BTS tower can support up to 20 Gbps speed. But in practical scenario, what the speed you will get per mobile devices? So that is around 100 Mbps. Okay, so per device or per mobile phone you can get 100 up to 100 Mbps speed. Okay, spectral efficiency that is increased as compared to the 4G network. It's a three times spectrum efficiency. So spectrum efficiency is basically defined. So how many bits can be transmitted by using a 1 gigahertz frequency. Okay, so if this is higher, then obviously your your speed will increase. Okay, mobility, if you are traveling with the speed of 500 kilometer per hour, still you will not face any kind of service disruption in 5G network. So its maximum mobility support is 500 kilometer per hour. Okay, latency is reduced 10 times as compared to the 4G network. So 4G network, it was the 10 millisecond, but in 5G network you can see it's 1 millisecond. Okay, connection per square kilometer, so that is the around 1 million connections. So this is helping the development or evolution of the IoT technologies. So so single BTS, there are 1 million devices can latch with this BTS. So this is the capacity enhanced in 5G network. Okay, network energy efficiency, so that is also improved 10 times as compared to the 100 times as compared to the 4G network. Okay, so what is this network efficiency? So if you are communicating with 5G network, so some energy is required. So here network efficiency means how less energy can be required to communicate with the 5G network. So it's 100 times better as compared to the 4G network. So which is helping the IoT devices which runs over the battery. So the battery life goes longer. Or even you can just relate with your mobile phone. If you have a 5G SIM card, so your mobile battery can go longer. So this is how the network efficiency 5G network offers. The per square meter throughput, so that is 10 Mbps in 5G network. Okay. So I have mentioned that the key focus area they have kept in mind to develop this 5G network. So these are the enhanced mobile broadband, ultra reliable low latency services, and massive machine type communication. Okay, so here you can see these are the three pyramids. So enhanced mobile broadband, so there are application which is like 3G video communication, ultra high definition screen, or video games, or augmented reality. So this type of application need good bandwidth, right, or good throughput to perform or give the good user experience. So and the ultra reliable low latency communication. So the application which are the mission critical applications like your remote surgery or self-driving car or industry automation. So they need a very low latency to just perform the job without error. So here this type of application can be evolved by using this particular parameters. Massive motion type of communication. So here the capacity of 5G network, that a single BTS can support up to 1 million devices. So in case of smart cities, there are multiple IoT devices can use the mobile network. So it should support that capacity. So smart city is evolving by using this 5G network, mobile network. Also the smart homes or smart building. So there may be multiple IoT devices. They can use the 5G network. Okay. So these are the three focus areas in 5G development. Okay. Now in case of 6G development. So 6G is not yet evolved, okay, and sorry, not yet developed, and its launch is expected by 2030. But there are a lot of development happening in different application front. Okay, so here you can see the AI native networking. Okay, in 6G. So what is AI native networking? So here the AI, artificial intelligence, that can just optimize the network traffic traffic flow, and also it can just detect the problem, what could be the problem, It's kind of predictive analysis, and also basis on that problem, it can take the necessary action to heal this problem. So this is how the AI is helping in the networking in 6G technology. Okay. The second development happening is the extended reality, so which is nothing but your virtual reality, augmented reality, and mixed reality. So how the user experience can be better as compared to the 5G or 4G technology, and how services are more useful to the users. Okay, so this service, keeping in mind this type of applications, so this development is happening. Autonomous vehicle or drones or VAV, UAV, okay, unmanned aerial vehicle. So this type of application can perform without any error. So the service level is defined in 6G. So how this type of application can work with the accuracy. Here new concept, you can see that in 6G there is a quantum key distribution. So what is this quantum key distribution? Basically, it is using the concept of quantum physics. Okay. So here the authentication key or encryption key can be communicated by using this technology. So what happens in this technology? So the polarization of photon is used to transmit this type of signals. Okay. So this is assumed that there will be no there will be no any hack or any compromise with this type of technology. Okay, so if anybody will try to compromise, the polarization of photon get disturbed, and immediately you can come to know that this particular thing is compromised, and the service will get stopped. Okay, so 6G is also offering the very good speed. Okay, and it is working in the 3D networking, so it can serve the ground as well as the air as well as the sky. Okay. Also, the coverage is improved. So we'll talk about the service level in next slide. But what about the major applications that 6G can support? Okay, so it's a holographic communication. So holographic communication is nothing but it's a 3D communication. So let's, for example, if you are talking remotely with someone, so that audience will feel that you are just talking face to face. So it will present you, your 3D picture as well as the your sound and background sound, and along with the acoustic. Okay, so it will just you will get the experience like you are talking in front of that person. Okay, so this type of development happening considering this 6G development. Industry 5.0. So Industry 5.0 is basically mainly focus on the cobot, so collaborative bot. Okay, and the repetitive task will be performed by the bot, and the creative task will be performed by the human being. So like 4G Industry 4.0, that the main focus area was the IoT and automation, but Industry 5.0, this is the cobot and green energy and resiliency. Okay. So tactile internet. So this is a very high speed internet, and it will work as a kind of real time. So if you send any kind of haptic signals, so that will be immediately communicated to machine, and machine can perform accordingly. So it's a very near time communication between human and the machine. Okay. A digital twin. So this is kind of a you can say you can build a replica of your production environment, and you can just test all your use cases, and once it is successful, then you can just replicate the same in your production environment. So 6G is helping to build this kind of digital twin, and how the communication can be smoothly through, and with the greatest speed it can be through. Okay. Massive IoT. So massive. So since the capacity in 6G technology is very high, device latching capacity is very high. So it is boosting the IoT front. Okay, and brain computer interface, that is nothing but with the help of artificial intelligence, the machine will understand your facial expression or your signal, and accordingly machine will perform that job, on the real-time basis. So that is called a brain-computer interface. And also I mentioned that there are a lot of development happening in the AI front. So how AI can be utilized in multiple network elements, and how it can support to the applications, customer use cases or applications. Okay. Here you can see the service level of 6G. Okay, so this inside diagram is the 5G diagram. Okay, the 5G KPIs, and the outer circle is the KPIs of 6G. So here you can see the peak data rate. So that is 1000 Gbps or 1 Tbps speed. So the tower capacity or BTS capacity is the 1 Tbps speed it can offer. Okay. But what about the actual user experience? So per mobile device can get up to 1 Gbps speed. Okay, so that is a 10 times better as compared to the 5G technology. Spectrum efficiency, that is also 10 times better. It's a 3x time improved. Okay, the mobility is also 2 times better. So if you are moving with the speed of 1000 kilometer per hour, so there will be no any service disruption. Latency is also reduced from 1 millisecond to zero 0.1 millisecond. So it's just a very minute delay, or you can say it's a kind of real-time communication. Okay, and the connection density here you can see. So it's a 10 million. So in a single BTS, 10 million devices can be connected. Okay, and network efficiency here you can see a 300 times improvement. So the battery in 6G network can go 300 times better as compared to the 5G technology. So or the battery of IoT devices can go 300 times better or perform 300 times better as compared to the 5G technology. So this is the drastic changes in the 6G technology we can see. Okay, the per square meter throughput is the 1 Gbps here in 6G technology. So there are a lot of improvement happened in 6G technology as compared to the 5G technology, and which is helping to some of the applications. Okay. Now I will talk about the satellite communication. So probably you have heard about the satellite communication nowadays, and there are a lot of development happening in satellite communication. So basis on the orbital position, these satellites are divided into three parts. This is called the low Earth orbit. Here you can see this is the medium Earth orbit, and this is the geostationary orbit. So satellite communication is not a new technology, it's available since long. But whatever the service level or whatever the parameters we are expecting from the satellite, so that was not fulfilling the modern applications. So hence this was not mostly used in the modern applications. Okay. But the entry of this LEO satellite, so which is fulfilling the service level is which can support the modern applications, and hence there are multiple development happening in this technology. Okay, so if you see the parameters, so this LEO satellite, the altitude can be a 150 kilometer to 2000 kilometers. Okay, and orbital period is 2 hours, means 2 hours. If this satellite in 2 hours it can make one round of the Earth. Okay, latency, these are the very important meter. These two parameters are very important. Latency is reduced from I can say in geostationary it's 700 millisecond, but here you can see it's a 20 to 40 millisecond latency. Okay, and speed it can go up to 1 Gbps. Because of these two parameters, so which is applicable on modern applications, right? Which is supplies the purpose of modern application. So hence this LEO satellite communication or satellite communication is helping to develop this type of applications and supporting this type of application and use cases. Okay. And global coverage, yes, obviously, since the altitude is very less, so it requires multiple satellites to cover the across the globe. So probably it's more than 1,000 satellites, and there are some players who are offering this type of services. So probably you have heard about Starlink. Elon Musk company, and Amazon Kuiper is also there. OneWeb is also there. So these are the service provider who has started the offering the satellite internet in market, and other services they are building over that. Okay. Internet of Things. So this is the technology internet. What is internet? So if you are communicating between two networks, that is called internet. So let's, for example, you are accessing internet from accessing Google from your mobile. So there are communication between your network, your mobile network, and a Google network. So this is called internet. Things means it's a smart object. So the object which can collect some information, which can communicate this information to the backend server, and backend server can process this information, and it can just perform some actions. So this is called a smart object. So IoT, there are four pillars. Okay, so data collection, data communication, data processing, and actuation. So these are the four pillars of IoT. So how data can be collected? So yes, there are different type of sensors which can monitor the changes in the environment. So like it's a temperature or humidity or gas, light, air quality, and so on and so forth. Okay. So if there are any changes in the environment, so it will just sense, and it will just capture the data. Okay. Then this data will be communicated by using the communication channels like 4G, 5G, 5G satellite, Bluetooth, RFID, fiber network. Okay. And once this data is communicated to the backend server, so this could be a cloud server, or your corporate server, or a server which is co-located in any data center or your corporate office. Okay, so wherein this data will get processed. And once this data will get processed, then obviously there will be some trigger point. So it will perform some action. So it can send the SMS, it can send you the calls, or it can just perform any other actions. Okay. So these are the four pillars of IoT communication. So here we can take an example of Alexa. Okay. So I am sure you know about the Alexa. Okay. So how Alexa works? So this is example of IoT. Okay. So let's, for example, if you say, Alexa, can you play the song of Kishore Kumar? Okay. So what happens? It will just the microphone of Alexa will sense your voice signal, and it will just send this information, collect this information, and send to the Amazon cloud services. Okay. So there is a separate services Amazon has built in their cloud servers. So that is called Alexa voice services. Okay. These services they have built. So the requirement, whatever the data it will collect, this sensor, it will go to the Amazon cloud by using your Wi-Fi network, home Wi-Fi network. Okay, so it will come here, and Amazon voice services will just convert this voice into text. Okay, so there will be a auto speech recognition technology will come into picture, and then this text will go to the NLUs, natural language understanding and natural language processing. So it will just understand what is the intent of this signal. Okay. So once it will come to know that that user is demanded to play the Kishore Kumar song, so it will go to the internet, and it will fetch the detail of the Kishore Kumar song. Okay, then it will just process it, and it will again convert this text into speech, and it will ask Alexa speaker to play the Kishore Kumar song. So this is how this Alexa works. Okay, so here you can see there are multiple IoT application in multiple industries. Okay, and this is, I have listed some few of them, but there are multiple use cases, and probably you can just Google it, and you can get in detailed information about all these use cases. So for example, in smart city, so IoT is being used for the smart parking management, waste management, traffic management, smart kiosk for bill payment, and other things, pollution control. So these are some applications. And manufacturing, IoT is being used for smart supply chain, remote monitoring, worker safety, quality control. Health, in healthcare, there is a smart hospital, ambulance management. Okay, so it will give the real time feed, where is my ambulance. Okay, so you can just watch it on the real time basis. Patient monitoring, a smart inhaler. Sorry. patient smart inhalers. Okay, so this is used for the asthmatic patients. Okay, in smart home and buildings, so here you can find the smart meter, smart lighting, surveillance, smart lock and smoke detection. Okay, in logistics there are fleet management, asset management, fast tech is also example of IoT, so which is used to collect a toll in highways. Okay, predictive maintenance, autonomous vehicle. In agriculture you can see smart farming, drone based farming, which is getting popular nowadays. Okay, smart irrigation, automated feeding, geofencing. So these are some few applications of IoT in different areas. Yes, so but you can just Google it and you can get detailed information about all these applications. Uh, here I will talk about the IoT architecture. So here this is the your IoT device. So here you can find the sensors, here you can find the actuators. Okay, and this IoT device will get connected with the gateway, and this gateway has the communication channel. So this gateway is nothing but your maybe your Wi-Fi router, so which has the internet access, and through this gateway it the information will come to the your cloud server, wherein this data will get processed, and basis on this processing there will be application which will use your data, and it will perform the task whatever you have defined the policy or rule, so accordingly it will work. Okay, uh, here you can see the low level architecture. Okay, so this is the IoT device, and in market you will find a different kind of IoT devices. So some devices has only the sensors and actuators, and they have the communication port, and through this communication port it will just communicate with the gateway, and it will go to the cloud. Some devices has the kind of this sensor actuators along with the communication, and also it will have some kind of data handling or processing power, so that there the little bit processing can be done at the IoT device level, and for rest processing it can go to the cloud services, and some devices can directly go to the cloud services. Okay, so there are multiple type of vendors available who are offering different kind of IoT devices. But let's, for example, there's some devices which need to connect with the gateway. So here sorry, so here you can see the gateway. This is the gateway wherein this IoT devices will get attached. Okay, and there are some specific protocols. So by using this protocol, they can communicate. This IoT devices can communicate with the gateways. Okay, so these are the protocol: BLE, Bluetooth Low Energy, Zigbee, and Z-Wave. So this Zigbee and BLE is the open source protocol, and Z-Wave is the proprietary protocol. So it's depend upon the use case. How is the use case? Based on your use case or based on your infrastructure, you can use this protocol. So BLE, the distance these protocols are supporting between 10 meter to 100 meter, and the data rate they are supporting, like BLE is 2 Mbps, up to 2 Mbps data rate. Zigbee is supporting around 250 kbps data rate, and Z-Wave is supporting around 100 kbps database. So basis on your requirement, based on distance between your IoT device and your gateway, you can just use these protocols. Okay, and from gateway there is a two main protocols that is used. Okay, so this is the MQTT, messaging queue telemetry transport, and this is the second one is the constant application protocol. So MQTT is a kind of a reliable protocol. It works on the TCP protocol. Okay, and constant application protocol works on the UDP. Okay, so if there is a constraint about the bandwidth, about the power, so probably this protocol can be used. But if you have the reliable network, or if you have there is no constraint of power, so you can just use the MQTT type of protocol to communicate with the cloud. Okay, a GPRS and Wi-Fi is used for communication as a communication channel to communicate data to the cloud. And here you can see the different servers in cloud. Okay, so there are the data streaming server, there are the API servers, there may be database. So it's a relational database, non-relational database. There will be an analytics servers for analysis of the data. There will be device management server, and there will be a policy server or rule engine which can define the task. Okay, so once the trigger point will create, then the call will be initiated, SMS will be initiated, email will be initiated, or other job will be initiated. So this is how this the complete IoT architecture and IoT devices works in this manner. Okay. Now I will talk about some of the industry use cases. Okay, so yes, this was the query why Mansi did not get feed. Okay, so so this is the example of IoT, and this cow is not a simple cow. These are the technology-enabled cows. So here you can see there is a RFID tag. So each cow is connected with the RFID tag. Okay, and this the signal will go to the IoT devices, and basis on the signal, the analysis will happen. Okay, so since Mansi already had the feed which is required as per their diet plan, as per her diet plan. So hence the feeder machine has not did not dispense feed to the Mansi. But while Nandini went, so this was the first time to Nandini, and the feeder machine has the information that Nandini has not got the sufficient feed as per her diet plan. Hence the feeder machine dispense feed to the Nandini. Okay, so this is the reason behind this. Okay, so there are named dairy industry who are using the IoT services. Okay, so here you can see, and by using this IoT services, they have improved their milk productivity, and also they have reduced their operational cost, their veterinary cost. Okay. The main use cases in IoT industries are the, let me move this. Okay, the main use cases of IoT is the cattle monitoring. Okay, so the temperature of the cattle, the movement of the cattle, the milk productivity of the cattle, also the location of the cattle, and the insemination cycle, their vaccination cycle. Each and every parameter can be monitored by using the IoT services. Okay, so this type of application has developed. Okay, and there are these dairy industries are using such type of applications. Okay, and we have talked about the automated feeder machine, chilling plant sensor. So yes, the temperature is very important in case of milk. Okay, so if there will be rise in temperature, so probably the milk got germinated. Okay, and it can go waste. Okay, so it's important to manage the required temperature in chilling plant. So if there is changes in temperature, it will send message to the supervisor that there is change in temperature, and you can just take any action to just protect that temperature what is required to protect the milk. Okay, so milk procurement. So the dairy industries, they are procuring milk from the farmers nearby villages, nearby farmers who lives in the nearby villages. Okay, and each farmer will get their RFID tag, so they can just scan their tag, and they can just pour their milk in the container, and this container will just weight their milk, and also it will just analyze their milk, the level of water, the level of fat, and basis on this information, the data will go to the application, and application will calculate their amount, or their amount basis on the quality of milk, and it will just send the payment to the farmer. So this is a completely automated process. Okay, so this IoT devices is used in milk procurement system. Milk vending machine. So I have seen some places wherein the milk vending machines are there, wherein you can just deposit your cash and it will dispense the milk. Or if you are a registered user, so you can just scan your RFID tag, and it will just dispense your milk. And as per the billing cycle, it will just calculate the amount, and it will send the bill on your email ID or your WhatsApp account. Okay. So these are some use cases which is being used in IoT in dairy industry. Okay. Now this example is related with your remote surgery, or I can say the robotic surgery. Okay, so this is one of the use cases of China. Okay, so wherein the patient admitted in Beijing hospital and doctor was based out of Rome, and the distance between Rome and China was around around 8,000 kilometers. And with the help of this 5G and fiber network, so they have performed this surgery successfully. Okay, so then this use case is related with the pancreas surgery, but apart from pancreas there are other patients they have performed for liver surgery as well as the gallbladder surgery. Okay, this surgery was got successful, 100% successful, and patient got discharged in 24 hours. So so how this remote surgery can help to the society. Okay, so this remote surgery can be used to help the underserved areas. Okay, so nowadays you can see the operation theater is building in a bus. Okay, inside a bus. So this bus can go anywhere, and a doctor can be based at their metro cities, and they can perform the procedure. So this type of application is already available. Okay, and also this type of application can help in battlefield, military field, disaster relief zones, ships, right, wherein the people stay for 3 months and 4 months offshore. Okay, or in the at the middle of the water, and cross-border experts. So no need to travel from one country to other country. So they can just perform remotely this type of procedure with the help of this type of technology. Here you can see the complete the importance of the communication channel. Okay, so here this is the patient and this is the robot, and this robot is connected with the 5G network. Okay, and 5G network it will come to their communication, satellite communication. Okay, and through satellite it will come to the console. So wherein the doctor is located. Okay, here you can find the doctor. So in this setup you can see they have used the geostationary satellite. Okay, but geostationary satellite is not recommended for robotic surgery because of the latency. So in geo satellite you can get around 600 to 700 millisecond latency, while the robotic surgery or remote surgery the latency requirement is less than 200 milliseconds. But what they have done, they have just adjusted in the robot front. So they have just adjusted this latency parameter in both the areas, and they have compensated this 600 or 700 millisecond latency by using some techniques here. Okay. So basis on this latency prediction, the robot will perform the action here. Okay. So this is how the technology is playing an important role in robotic surgery. But yes, the LEO satellite will play a very important role here. Okay, because its latency you can get is 20 millisecond to 40 millisecond. That is good enough for this kind of surgery. Okay. Here you can see the use case of IoT in warehouse. Okay, and this is a well organized warehouse, but in practical, so the warehouse is not this much organized or arranged. So the goods are dumped here and there, and it's very difficult to find the goods. Okay, so IoT can help in this warehouse scenario, and you can just have in time inventory. Okay, the basic challenges in a warehouse scenario is that lost or misplaced assets, manual or error-prone inventory counts, lack of real-time visibility of assets, and time-consuming audits. Okay, so how this IoT solution can be benefited? So you can have just in-time inventory. So anybody can just search that RFID tag in the application, and it will just immediately share the location. So what happens? So each and every consignment has the RFID tag, And this RFID text sends signal, and there will be a RFID reader. It will just continuously reading the information about the inventories. Okay, and this RFID reader is back to back connected with the backend application, and it will just send data to the backend application. So you can have the all the inventory in place, and any new person they can just search that RFID tag number, and you can he can find where is this consignment is placed. Okay. Also, if you have the proper inventory, so you can just have the purchase planning and budget planning. So whatever the procurement is required basis on your forecasting, and also you can get the real time location details, movement, material movement. You can just prevent the asset loss, theft. So these are some use cases in a warehouse scenario. In smart city project, so here you can see the smart meters. Okay, so in a smart city project, every meter is replaced with the smart meter. So in even in Pune, you can see the meter is getting changed. So it's replacing with the smart meter. So here we need to understand that what is the conventional approach. Okay, so in conventional approach, what happens? The electricity board will appoint some agency who can go to each and every house and collect the reading of meter. Then it will go to the office, and it will hand over this data to the data operator. Data operator will feed this information in the application, and basis on your billing cycle, the amount will be calculated and your invoice will get generated. And then this agency person will just come at your premises, and it will just drop the electricity bill. So this is kind of conventional process. But how IoT is helping this process to make automated. Okay, so now the meter is replaced with the smart meter, and smart meter is connected with the GPRS modem. Okay, so that is nothing but IoT devices. Okay, so whatever the reading that will come from the meter, so this reading will get transmitted to the backend application, backend server. Okay, and backend server basis on the billing cycle, it will calculate all the readings, and the invoice will get generated. And this invoice will go to the it will come to your WhatsApp, or it will come in your email box. And once you get this invoice, you can just make an online payment, and this is how the complete process will get automated. So there is no any manual intervention required. So this type of things are happening with the help of IoT. So the basic challenges and benefit is like there is no manual efforts. There is no chance. The main challenges is the manual efforts, delayed billing. Okay. The benefit is that you can get the accurate billing. There will be no any human errors, or no any manual efforts. Also you can save some time, and it can be accurate readings. Okay. This is the example of irrigation, how IoT is helping in irrigation. Okay. So probably if you belong to any village, or you visited any village, so you can just imagine what is the life of a villager. So the life of villager is not luxurious as we live in our city. Okay, so they are facing the resource crunches. So in city we can get 24/7 kind of electricity, but in villages they are getting only hardly 8 to 10 hours electricity. Okay, but during the crop season, so it's very important to have the irrigation at the time. Otherwise, there will be impact on their crop production. Okay, so in conventional tube wells, so you need to stay the whole day, whole night in your farm, and you need to just irrigate your crop. But nowadays, with the help of IoT, what is happening? So there are smart tube wells are there in market. Okay, so these smart tube wells are coming with the application, and in application you can just see your tube well is running or not, and remotely you can on off your tube wells. Okay, and also you can have the some other information like how long it is running, and how much, what is the your water flow level, and how much water is flown. So there are multiple analytics you can find. Basis on that, you can just plan the irrigation. Okay, the basic challenges in this scenarios, right? So manual efforts, human error. overuse of water and electricity, and if you are over that irrigate uniformly without considering the moisture, soil moisture or crop, okay, and wastage, lack of a real-time consumption insights. So these are some challenges. The benefit apart from this is that the IoT device can help in the soil moisture, temperature, humidity. So this can be monitored through the IoT devices. Based on that, the farmer can plan the seeding or sowing. Also, it will help you on the saving of energy and water. Okay, and that time saving as well. So this is how the IoT can be used in irrigation. Okay. Now, apart from this technologies, there are other technologies, next generation technologies are available in different zones. So in voice communication, in data communication, in cloud communication, in security. So there are many technologies are available. Okay. So we have talked about 5G, 6G, satellite communication. Also, Wi-Fi is playing a very important role. So you have heard about the public Wi-Fi in airport, in railway stations or any stadiums. Okay. So nowadays the Wi-Fi services is offering you a great speed, like around 50 Gbps speed kind of speed in Wi-Fi. So earlier there was only technology like 802.11 A, B, and C, so which can just offer you a 11 Mbps kind of speed. But nowadays you can get around 55 or 50 Gbps kind of speed in Wi-Fi technology. Open RAN, so this is the Open Radio Access Network. So what happens? So generally nowadays there are some organization has monopoly in RAN network, there are limited organization, ZTE, Huawei, Siemens, Nokia, Ericsson. So this type of OEMs has the monopoly in this area. But problem here is that, so if you subscribe or if you procure one devices, then all the devices related with this radio access network you need to procure from that particular OEM. So Open RAN gives us the flexibility wherein it is divided into two parts, software and hardware. And hardware can be from any operator or any OEM. So it's not necessary that you can just purchase hardware from a single operator. So this technology is getting evolved, Open RAN. Okay. SASE, so this is the secure access services. So how the internet bandwidth can be filtered or secured at the service provider level. So this defines the security level in the network, or as a user you can use SD-WAN. This is the WAN connectivity, software defined WAN connectivity. So how you can connect one office to other office by using this technology. So this is divided into two parts: software, which is the controlling power, which has the controlling power, and WAN equipment, which is the underlay services or connectivity that can be managed through the WAN. So SDN, software defined network. Okay, so here software can configure your network elements remotely. ZTNA, zero trust network access. So this allows this service is authenticate each and every, whether you are inside user or outside user. So that will be authenticated. Each and every user will go this authentication. Network as a services. Now this is a service where all the network elements can be offered as a service. Okay, so as a enterprises or as a customer, you need not to purchase any kind of services. Okay, so that is just provided by service provider, and then the configuration, management, maintenance is done by the service provider. Okay, AI networking. So in 6G network, we have talked about AI networking. So this AI will help to optimize the traffic pattern. It will just detect the problem, and the proactively it will rectify the problem. Multi-cloud networking. So nowadays there are multiple cloud service provider like Microsoft Azure, Amazon Web Services, Google Cloud. Okay. So being a customer, how you can access all this cloud service provider based on your application without establishing a connectivity with each and every cloud service provider. So there is a middle layer which has the connectivity with all the cloud service provider, but as a user you can just access your services, and this service will come to your middle layer, and middle layer will define this service will be served by Azure or AWS or Google. So this is called a multi-cloud networking, intent-based networking. Okay, so whatever the your intent, so you need not to configure the network element, right? So you need to just define your intent. Intent is nothing but your requirement. Basis on your requirement, it will the network element will get configured and it will perform the job. Digital network twin in 6G network, we have discussed about that. You can create a prototype and you can do your R&D and testing, and that same thing you can apply in your production environment. Quantum networking, so this is related with your quantum physics, right? So how the polarization of photon can be sync, and the communication can be established. Okay. Collaboration, we have discussed about this Microsoft Teams. Okay, UCOS, Unified Contact Center as a unified communication as a services. Okay, so this is the communication platform wherein you can have the audio, video and wave communication by using a single platform. Contact center as a services, so this is generally used by the call center, KPO, BPO, wherein the cloud-based platform, they can just make the voice call, and there are different type of elements, IVR, ACD, and also the predictive dialers. So this type of services are used. Communication platform as a services, so basically this is the kind of omni-channel channel, so wherein in a single platform you can have the email communication, you can have the social media communication like your Facebook, Instagram, your WhatsApp, your SMS services. So this type of application is served through this communication platform as a services. So this all is the next gen communication technology, and I think this is my last slide. Okay, so that's it from my today's discussion, and thank you. If you have any questions, so you can just post your question in chat window, and I will try to answer that. So that's it. Thank you. So over to you, Dr. Gopa.
Yes,
Thank
sir.
you,
So
Yogesh
we,
sir. We
yes.
now welcome the questions for you. So, dear participants, the forum is now open for questions. Please share your queries in the chat box. And I would request the co-coordinator to kindly announce the question posted in the chat box to our speaker.
Okay, so I will begin with the first question. It was asked in the beginning of the session. So one of the participants, they wanted to know that which technology came before 5G. So they wanted to know. Sir, you are on mute. You will have to unmute yourself.
Sorry. So
Yes, sir.
before 5G, yes, there was the 4G, and 4G was the completely under the packet networking, and this is the one pure network with the packet switching. Okay, and we have discussed about the KPIs of 4G technology, wherein you can get the speed of 10 Mbps in a single mobile device, as well as the latency is the 10 millisecond. So this was the KPI in 4G. After 4G, the 5G technology got evolved, and wherein we have seen the speed got increased from 10 Mbps to 100 Mbps, and latency is from 10 millisecond to 1 millisecond. So this type of enhancement we have seen in 5G technology.
Okay. Sir, the second question which has been asked by one of the participants, we want to know that can you please explain in simple terms how 6G can achieve 1 Tbps data transfer as compared to 20 Gbps in 5G?
Yeah, so basically there are not a single component in this. So the development happening in the antenna front, radio access network front, as well as the hardware and the network hardware. So these are all are getting developed and evolved, right? So basis on that, the capacity and latency is defined. Okay, so nowadays there is not the physical hardware. So all the hardware is getting virtualized environment, and the hardware, the application is used in the virtualized scenario. So which gives us the speed as well as the processing power. So in cloud, what happens? So it offers you the flexibility. So at any given point of time, you can just scale your resources. So it's not like a hardware wherein you can get a fixed configuration like 2 GB RAM and 4 core processor or a 500 GB hard disk. It's not like that. In cloud, if there is a traffic increase, it will just increase the resources. So basis on those technology as well as the development happening in the radio access network, so there are MIMO antennas are getting used. There are chipset antenna chipset is getting evolved. Basis on that, this will define the speeds, right? So it's just a
Okay.
complete collaborative operation. So it's not only the antenna will give you this kind of speed. So antenna along with the backend network elements. So this is the both the collaboration. This kind of SLA or service level can be achieved.
Okay. So in further to that, somebody has asked that can you please explain in simple terms how such big jump is possible? So as mentioned by you, with the help of hardware, it can be possible, this big jumps. That's what my understanding goes, sir. Hopefully
Yeah.
that's what you're trying to say. Yes, sir. So one of the other questions that has been asked that South Korea is first to launch 5G in 2019 and it came to India 3 years later. So how India is prepared with teleservices infrastructure to be the first to launch 6G commercially?
Yeah, so it's not related with just a technology. It's also related with the business perspective, right? So in India, so even you can see, 3G is not matured in India. So once we started using 3G, then 4G came into picture. Okay, so it's related with the current investment. Okay, whatever the telecom service provider operate invested in the current technology and how they can swiftly adopt the new technology. So it's a depend on that. So it's
Okay.
just not only the new technology coming and we can just adopt, but we need to also check our investment and return on investment. Basis on that, the service provider is planning their enhancement in services.
True that, sir. So one of the participants, they want to know that is there any future for AI-driven wireless networks? So they want to know.
Yeah, obviously. So even you can see in Wi-Fi I discussed, right? So earlier there was the Wi-Fi 1, 2, 3, 4, 6, 7, 8. Now the 8 is going to launch around in 2028. So the every technology is getting evolved, and even every technology is just trying to explore how AI can be used in those technologies. So yeah, it's no doubt AI will capture in each and every parameters in each and every technology.
That's true, sir. So I think I'm able to cover the most of the sessions. And is there any more questions? I'll request. Yeah, so there is one more question. So coming off 6G, will it affect the carbon emission? And if it does, how?
Yeah, so carbon emission. So the industry 5.0, right? So it's this focus on the green energy, and even in 6G KPI parameter, you have seen the energy requirement is less, and it's a 300 times as compared to the 5G. So if the energy or power requirement is less, obviously it will help.
It will help. So there is one more question that 5G is a multi-access technology. So how advanced 6G will be, and will all multi-access technology network connection, how advanced 6G will be, and what all multi-access technology network connections will it have?
So I didn't get this understand this question properly. So
The question I'll reframe. So 5G is a multi-access technology like satellite connection. So how advanced will be 6G be, and what all multi-access technology network connections will it have?
yeah. So in 6G also we have seen the KPI parameters. So KPI is 1 Gbps speed per device and latency is 0.1 millisecond, right? So and also the development happening in the networking 3D networking. So it can support you the in the ground as well as the air as well as the sky. So there are also the NTN chipset is getting developed. So non-terrestrial network chipset. Okay. So if this chip will get mature, or this technology will get mature, then in you can use the satellite communication like you are currently using as a mobile communication. So once this chipset will get developed, then this chipset will come into your mobile phone and or your any networking hardware, and directly you can just latch with the satellite. So but you cannot imagine that this satellite will replace the complete other network elements. Okay, no. So it will work as a collaboration. So wherever the signal, you will not get that signal from the 6G or 5G, so the satellite will latch, will come into picture, and you can just use the satellite signal and you can connect with your network. Okay. So this is under the development right now. There are a lot of things is happening in 6G front. So probably we can see how the thing will shape in around 2030.
Huh. Yes, sir. So I'll take just one last question because we are in next session also scheduled. So one of the participant, they wanted to know what about the carbon footprint as we use AI with multifold processing and how we can reduce the carbon emissions.
So yes, so the device whatever is getting developed nowadays. So generally focus is that how the energy consumption can be reduced. If there will be less power, there will be a consumption of less power. So obviously the carbon footprint can reduce, right? So the main focus is on the green energy, how the less energy can be used. So that is the main focus on the current technologies.
Okay. Okay. So I think we will conclude the question answer session. These many questions were there. So thank you so much, participants, and over to you, Dr. Gopa.
Thank you, Pratha. And thank you so much, Dubey sir, for that insightful session. The way you explained the transition from telephony, RAN elements, 4G, 5G, and finally to 6G, and its impact on IoT latency and real time communication, and the opportunity it opens up for smart cities, autonomous systems, and cloud driven solutions were truly enlightening. Your practical insights from industry application, especially on how enterprises can adopt these technologies to transform business communication, have given us much to reflect on. And so we are finally happy that Mansi and Nandini got their feed. And on behalf of IMDR and all the participants over here, we sincerely thank you for sharing your expertise and valuable experiences with us. Thank you so much, sir.
Thank you everyone. Thank you.
We now move on to our next eminent speaker. It's an honor to welcome our overseas speaker, Mr. Rashid Jain, a senior AI product and engineering leader currently serving as engineering manager at Meta. Mr. Jain is an alumnus of IIT Kanpur and IIM Bangalore and has over 25 years of experience across some of the world's most renowned organizations, including Google, eBay, Salesforce, CarMax, IBM, and Workday. At Google, he played a pivotal role in the Site Speed initiative, making Chrome browser faster, a contribution that has earned him a patent and global recognition. At eBay, he led global teams to develop large scale AI driven advertising solutions, generating multi million dollar revenues. And at CarMax, his leadership in AI ML solutions contributed to Forbes, recognizing the company among the top 100 CIO innovations. Currently at Meta, Mr. Jain leads engineering initiatives around AI driven safety and protection tools, particularly focusing on creating safer digital environments for Instagram users. His expertise spans AI, machine learning, generative AI, cloud infrastructure, and large scale data systems, making him one of the most versatile leaders at the intersection of business and technology. With multiple patents, Critical Talent Award, and a strong record of scaling engineering excellence globally, Mr. Jain continues to be an innovator shaping the future of AI powered communication. So, dear participants, please join me in extending a warm welcome to Mr. Rashid Jain, who will be bringing insights on AI in communication networks. Over to you, sir.
Thank you, Dr. Gopa. That was fairly elaborate and kind introduction. A bit too much, so thank you. But hello, everybody, and really glad to be part of the session and talk to everyone. Um, so I'll get started unless anyone has anything to say. Let me project my screen. Um, uh, does everyone see my presentation?
Yes, sir, it's visible.
Okay. Sounds good. I can see the chat window when I'm presenting. So if there is anything, please, stop me and I'll switch. All right. So topic that I thought I'll talk to you about, which is close to what I'm working now, is how's AI being used in social networks, current state, application, and future. This can generally be extended to other industries and applications as well. And yeah, but we'll focus on social networks and see how it is today, where it is going, how it is being used, and so on. So like Dr. Gopa said, I work at Instagram, and current in my current role we are working in using AI to protect teens from abuse and harassment, which is a very critical problem for Instagram because we have a lot of teenage users. And as a parent of a teenager, it's closer to home for me because I want to keep them safe and they are on Instagram pretty much all the time. All right, so I'll talk generally give an introduction and talk about the market opportunity, how AI is used today across major social networks, and then opportunities, risks, and regulation, and future trends, and how you should be looking at it. And then we can move over to Q&A. Um, So what is AI? I just briefly saw previous session, so it's probably too basic. But essentially, it refers to computer systems that can perform tasks that require human intelligence. Intelligence is the key here because in the previous generation of industrial revolution, we looked at automation in general, but AI has added that component of intelligence that we are accustomed to see only humans do. So it includes tasks like learning, reasoning, and problem solving, which essentially, were hand coded or used existing knowledge as opposed to modern day systems that learn from data, then understanding language. So today, AI in general, it's a very broad term, but it specifically refers to machine learning technology where the machine is automatically learning. And more so today, as machines become large clusters and bigger, it's deep learning, which is kind of very close to how human brains operate in terms of layers of neurons. It was founded in 1956. A lot of people don't know that AI goes as back as 1956 when we did not really even have neural networks. And a scientist called John McCarthy uh, coined the term in Dartmouth College based on the state of computing at that time. Essentially, what AI does is it learns from vast amounts of data. It identifies patterns and relationships. The most common AI applications that people have used, excuse me, are recommendation engines. Like if you use Netflix or say eBay, Amazon, it suggests you what you may like next. And often people do. Then chatbots and virtual assistants that have come in recently with ChatGPT and OpenAI, and then spam filters, which started in late 90s, where emails were automatically classified as spam if they were so. And all of these technologies used AI underneath. So now AI is kind of leaps and bounds ahead of what it used to be. Generative models is what you see in ChatGPT. They are designed to generate text. That's all they know. But in generating text, they are able to do reasoning and problem solving. So that's advancing very, very quickly, including on the hardware side as well as algorithm and capabilities, model size. So it's really, the people who have invented, they are saying it's going to be, close to what humans do very soon, sooner than what people had expected. It includes now text, images, audio, and video. This is called multimodal, where you are communicating with AI on multiple ways like text and image. The thing that is missing here is multisensory, where AI still can't taste or smell. or feel. But even that is being researched by using robotics in various labs in various places in the world. And it's integrated in consumer applications and social platform. The other important thing that governments are racing for is increasing regulatory and safety scrutiny, like privacy. Child safety is a big area. Misinformation, you can generate videos of anybody saying anything in any voice today. But the market opportunity is huge. So what AI started to do already since 1990s is automate repetitive tasks. You can have it process spreadsheets and a lot of common business processes. And knowledge work became more efficient as you can create digital libraries and search. Instead of reading through a whole bunch of documents or relying on only people who had the expertise on a lot of different subjects, you could build digital libraries and search. So productivity was the first area where AI made an impact. Today, McKinsey forecasts that it's going to be $2 to $4.5 trillion in annual economic benefits. And four core areas where this economic benefit is concentrated is software engineering, customer operations, sales and marketing, and R&D. But that economic value does not fully capture the overall economic value because there is other areas where it's not visible what AI has impacted. Like if you are able to build a product or write a research paper using a digital library, which is kind of searchable through AI, that economic value may not be directly visible as opposed to just the fees you might have paid for using the digital library. So indirect impact of AI where it has amplified other trends, speed up innovation cycles, and enabling new possibilities have not been captured in that value. So per McKinsey, even that value by 2040 would be more around 20 to 25 trillion dollars. That's how big AI's economic impact is. And technology is evolving quickly. So McKinsey's impact, even McKinsey can't foresee really how AI would land in by 2040. And it's probably improving faster than what most people are expecting. And these days, you might have heard the term LLMs, which is large language models. And they are the future. They are the areas because they are very generic and they can be used by business users to very quickly do tasks which some time back only advanced machine learning engineers or experts could do. So now business users can do that without deep technical knowledge. And agentic AI, where agent can be created very quickly using AI, a software agent which can really do tasks, relatively complex tasks that human agents used to do or do today. Um, how value is captured in AI and how it is measured. So in e-commerce sites, personalization and recommendation is a big application area. So everything around AI has to be measured. If you are, there is also a lot of investment required, not only to build the AI product, but also to maintain it going forward because data pattern changes. So you have to refresh those models and, continue to operate and maintain them. So there's a high maintenance cost. So you have to measure how it's benefiting your users. So engagement lift is what they look at for recommendation and personalization. Are users clicking more? Are users coming to the site more? Are they spending more time? Are they able to get to what they want faster? Then on ad creating, targeting, and creative optimization, that's a big area of AI application. People look at ROAS lifts. ROAS is return on advertising spend. So if you are using AI like Google or Facebook are two biggest, global AI digital ads providers, they whatever changes they make in the AI targeting, they look at if the advertisers spend had higher return, more traffic, more action from users, and so on. Then creators are using AI for content generation and monetization. They look at ideas and other metrics. So automation and moderation AI, they look at cost reduction. Are we able to achieve any cost reduction in using AI? Then more recently, audio, video, AR and VR immersive experience, they look at higher lifetime value. How does it work? Very high level overview. So the core mechanism of AI recommendation engine starts from collecting data. So like Amazon products you may like, they collect user and item data, and most people know that data is money these days, right? And anything you do online can become your data getting to the companies who are serving you the product. Um, Mostly there are strict regulations, but it's not implemented everywhere. In US, regulations are very strong in Europe and US, and they're implemented fairly rigorously. But starting the AI modeling starts from collecting user and item data. They look at past behavior, current preferences, and what are the product features and how do they map to the user preferences. They use algorithms like what is called collaborative filtering. If you are closer to engineering team in the space, you might hear these terms: collaborating filtering, content based filtering, and these days deep learning models, including LLMs, which find patterns and predict what a user is likely to enjoy. And that is used everywhere, like in Netflix or Amazon or eBay. And lastly, once they figure out what users are going to like, they rank and personalize results in real time with machine learning models, and these models adapt as more data is gathered. Uh, and real-time personalization could look like, one day, and yesterday you might have watched an action movie, but today you are in mood of watching a more family movie. So when you are browsing through Netflix, you are clicking on family-related movies. So then they reorient what they are providing you based on your immediate activity. So often, long-term, short-term interest, what you are in the mood of doing right now in the context and session, that gets higher preference in these models than what you have done yesterday or historically. Content moderation and safety is another area, and this is what I am working on these days. They automatically try to detect what if a content has any hate, abuse, sexual content, and that automation it is scaled easily by AI as opposed to humans. That there are challenges, of course, so it is error prone. Generally, AI has a little bit margin of error if you're using in an application. So context sensitivity, the multi-model can be misused. Like people can learn how a product is detecting this and then scam around it. And then these models also give false positives. So they may end up blocking good people and trying to block some of the bad content. So that is why human in the loop remains essential. Human in the loop meaning once AI gives a recommendation, say content is bad, often you don't go ahead and just remove that content, but have a human reviewer review it. At scale of Meta, it's hard. So we review mostly borderline cases, but something that is very obvious as not human reviewed today. But people can file appeals, and there are edge cases. These cases can be culturally different. In different culture, hate and abuse content is considered is very different. In Europe something can be very strict, but in America it can be less strict, right? So there are always edge cases in these type of things. uh, then creator tools, ads, and commerce. These are the three big areas of AI usage. Some of the use cases include AI assisted editing, and then in video sites, thumbnail clip generation, then captioning speed up creator workflows. Then ad creative optimization also uses generative variants. This is more recent. And there's something called A/B testing, meaning, in large sites like Meta and Google, they will segment users and they will show some content to users A, and then they will continue to show existing content to users B, and then statistically infer whether users liked content A or whether it worked better. And if it does, then they would just launch content A to everybody. So before launching a product, they would do these types of what is called A/B testing. And then, visual search is becoming very common these days. You can take a picture from Amazon or eBay search and then use that picture of the product to actually search similar products. And then, recommendation continues to improve using different varieties of inputs. In Meta, so I'll now talk about specific social network sites and how they um, are using AI application. I just realized I'm going faster than I'd planned. So if there is any question, Dr. Gopa, please do stop me because there's a lot of content.
Sure, sir, sure.
If there's any question, we can stop here.
Sir, I can see one of the questions in the chat box. One of the participant is asking, are there any AI recommendation for people well-being in the organizations?
For people, what? Sorry.
Are there any AI recommendations for people well-being in organizations?
That's a great question. So one area is productivity. So AI is mostly used as an AI assisted form. So I mean, this is I am not sure if you mean by healthcare and general work-life balance. So AI productivity is a big use. For example, these days all the content in the organization, both your own content, public content, is fed into large language models with, of course, privacy controls, and you can easily search information. You can easily organize content by projects, including any files plus any chats. It also unifies interface. For example, if you are using a chat window like team chat, right, then you can in real time search organization content and ask the team chat for an answer, like, and it can behave like a participant. um, and there are so many different ways productivity is being improved by AI that is generally helping people also take care of very painful mundane tasks. Like you want to spend more time interacting with your customers in your job or doing value added stuff. So a lot of non-value added mechanical things are being taken care of by AI. So that's helping. And then say calendaring, scheduling, and a lot of different things in terms of improving productivity, improving work-life balance is being used.
Okay, sir. Thank you so much. And there is one more question. So somebody has written that how to write effective AI prompts. Can you suggest any effective examples of AI effective prompts for specific task?
Yeah, that's a great question. AI engineering is moving to prompt engineering. Actually, it's already moved. Next level is context engineering. So prompt engineering is a big part. You can use LLMs and chat GPT, either in a poor way or in a great way. It's more depending on the prompt you write than the model itself. In fact, prompts have made such a big impact. It is so important that when OpenAI launched GPT-5, their own studies said it's not working in some areas. But then there are some application use cases. They came in, they said, no, GPT-5 is working better than GPT-4 because they were able to tailor prompts and tests in ways that were more effective. So now standardized tests may actually not be the best way of looking at the model improvements because certain type of prompts work better for certain models. So as you get deeper, there are so many models. Google has Gemini, then Claude, then Perplexity, then OpenAI, and each one of them can do different and better with certain applications and prompts. So now to your question, there are a lot of services and websites also that do prompt engineering. I can't cover in this session. But if you look it up in on LinkedIn, there is, I'll definitely advise people to do prompt engineering if you are going to use this in a big way and seriously. Because a lot of your tasks are not just asking questions and asking for information, but they require deeper thinking. So for example, there is something called chain of thought. And in chain of thought, you ask a complex question and then ask the model to do it step by step. And you just tell it, do it step by step. Then it will use chain of thought prompting, and it will start with the higher level, like try to understand what you are asking for. It'll break it up into smaller tasks and then tackle each one of them. So it will go step by step. So that is chain of thought reasoning, and so on. There is also RAG. RAG means, LLMs and these models can hallucinate. They can give you false information, especially in a conversation. As you keep going deeper and deeper, they can hallucinate, and they are not designed for facts. They are designed for generation of content, and they are doing reasoning as a side effect. And I can go deeper into it with this, with some interesting comparison with human mind. But to prevent hallucination for important use cases, what you do is you first search for information using AI, then feed that information to the model and ask it to reason and come up with answers. So you provide the model knowledge, and that is called context. So prompt plus providing it knowledge is called context, roughly. So it's not just about prompt engineering, but also context engineering, where what knowledge you provide to the model to get the ultimate solution um, is called context. So in the terms of providing knowledge, you can also tell the model, this is how you should work. Like third, there is above third floor, there is fourth floor, above fourth floor, there is fifth floor. I'm giving a simple example. So give it some patterns, and then it'll learn in real time and tailor its response based on what you want. So context engineering is a very important thing these days, but then it makes the prompt so big that it starts to fail. So models have few limitations that today humans don't have. And models have, as people are comparing models with human brain, and as they're converging in their abilities, there are some key differences where some models have huge advantage that humans can't ever have, and some advantages humans have that models are still trying to figure out. One of them is models have limited ability to process information at one time. It's called token limit. Now, token limit started from 4,000, 5,000 tokens or words. Now it has gone up to millions, which is a significant improvement. And images, small images, can generate 7 to 8,000 tokens. So if you say put in like a video for the model to analyze, or say 10, 20 images, then model starts hitting limits. And when you are asking questions and answers within the same context, model keeps entering, adding what is in its memory in terms of tokens. So after some time, model runs out of the limit and it'll either hallucinate or stop. So humans are different. In human cases, when we say, if you're playing, say, boxing, imagine the amount of information your brain absorbs to really return a response and how quickly it does. So if you're boxing, then the other person, your eyes are observing the other person in current state and it's moving. It is developing the pattern. So the amount of pixels your eye takes in is massive. Models can never take that. And then in real time, it is stored in different levels in your mind. It is processed so quickly into the inputs, electric signals your brain takes, and then quickly analyzes, uses the right part of the brain to come up with the response, and then transfers that action and instruction to your body, and then you respond. So the amount of information that your brain takes in, models can't even take a small part of it. That is one part. Second, models can't do short-term caching today. What they have to do is they have to take inputs every time, and they forget. It might appear to you that the model is remembering what you just asked, but it does not. It is the outer layer that keeps it and then sends the previous information along with the new question every single time. So the context keeps getting added. So that is one big gap that companies are working on. So that's a limit on number of tokens. Second is constant learning. So as you grow, you're constantly learning new things. Model cannot. Model has to be retrained at a point. So at some point, more recently, say Chat GPT was trained in March data or something. So beyond that, anything that might have happened, it doesn't know. So what Perplexity does is, or Google Gemini does is, it does a real-time search and then feeds that information to the model. So that's how it appears more recent. But so on. There are a few limitations that they're working on. So I hope from prompt engineering we went all the way, but prompt engineering is very important. There are a few different techniques, and I'll suggest doing some course. And I gave an example of chain of thought.
Yes. Sir, when you were talking about concept of rank, this also question came to my mind. So somebody has asked one of the participant that what are the ethical concerns of related to same about the AI, and will it replace human jobs altogether in future?
Yeah, that's a very good question. I have a slide later on, but I'll touch upon it a little bit right now. Ethical concerns are very, very broad. Not just about jobs, but also about safety, spam, and all of that. It is a very big concern that people are really thinking, the thought leaders who are thinking about it in a very serious way. While there is a contention, you don't want to slow down the speed of innovation because there's also competition between countries and other things. So that's a trade-off. There are a lot of different cases of ethics. Spam and fake is one, but the other is bias. So there is an example, like if you are, say, in your city, there are certain areas where poor people live, and there are certain areas where rich people live. Poor people can be congested, living in congested area, and might have more car accidents than in neighborhoods where rich people live. So when you train a machine learning model to say generate insurance premiums, you may bias it to charging more towards poor people because they are. It's just coincidence that they are living in a neighborhood which has more accidents, but the model may think that it is them. Similarly, it may bias towards men versus women in jobs because there are just more men applying or more men in that industry. So a machine learning model can get biased, and it has not been trained to debias like humans are being trained, right? And humans can get biased as well, but machine learning model is purely biased. So that's a big ethical concern. Um, Regarding job loss, there are multiple views. Obviously, some tasks will get automated, but then the positive side is people are going to do more value added things, right? So AI assisted will be much bigger area than direct automation by AI. That said, like 20 to 40% of tasks today that people do will get automated. But that may mean that people can do better tasks. The second part is, companies need to constantly innovate, and countries need to constantly move ahead of the cycle for creating new types of industries, new types of jobs. Now, if you look at McKinsey projections for India specifically, in the last decade, agriculture has grown by from $250 billion to $500 billion, and in next years, 10 years, it'll go to 1.5 trillion. Next 10 years, it'll go to 3+ trillion. It's growing much faster than Indian economy. So why an Indian economy has like 50% of the population is working on farming, whereas what is happening in the world, rest of the world is since 1997, half of the farmers have left. There is a huge amount of food shortage that may happen due to not only wars, global warming, and other things. So India has a big opportunity in farming. Today, 40% of Indian farm output is wasted due to lack of cold storage or infrastructure, bad weather conditions, and all that. But India can get its act together to really become global farming exporter. Similarly, there are many other industries that will go very quickly. So what will happen is jobs will shift towards more value added things and newer industries. And then it has been a trend for last 150 years. If you look at industrial revolution, had disrupted a lot of homegrown businesses. And then, like khadi and other like people used to produce, make their own clothes, right? And now everybody kind of buys made in China kind of clothes, right? So people, there will be disruption, but that disruption has always happened during industrial revolution, knowledge revolution, information revolution, and now AI, and people have to adapt.
Okay. Sir, I mean, since you mentioned about multiple industries that which has a direct which on which AI will have a direct impact on. So one of the participants, they want to know the impact of AI on research, because again this will have some overshadowed impact also.
Absolutely. Research, like I had mentioned, is one of the four areas where AI is having a big impact. And I'll give you an example. I am a metallurgy engineering. I did metallurgy engineering at IIT Kanpur long time back, and then I switched to tech. So new material research can take, I forget the number, like 10 years or more, to build a new material. Like, for rockets, you have composite materials and so on. It takes a lot of research. So you have to look at all the combination of materials that have failed and then learn a new one. So to build a new material, there are two basic tasks. First, look at what combinations have failed, which is huge. And then try the new combination which has not been tried before. And so trial and error for each iteration, you have to really analyze what has failed in past for all these times. So that takes a long time. So Microsoft tried with LLMs, trying a new material research, and LLMs built that a new material very quickly, like in months, what used to take decades, because now the model has far more expertise in analyzing what has not worked. While it may not have that much human intelligence still to apply a judgment on what should we try, it is very effective in crossing out what we shouldn't try, because that takes a lot of knowledge and a team to kind of try, so on and so forth. So R&D in terms of iteration, so research is all about iterations, and you have to see there are 99.99% cases may not work, but to get to the 0.001, you might have to go through a long cycle, and that long cycle AI is really cut. So in a lot of different areas, medical research, things like cancer research, generating new medicines, AI has really cut down the research cycle.
That's true, and of course that will be beneficial for us all. So one of the participants, they want to know that there are two prompts which are given. So explain photosynthesis is one of the prompt, and another is explain the photosynthesis like I am a 10-year-old. Now for one, AI will give a normal explanation, and for the other, a very much simpler explanation. So how is an AI interpreting these prompts? They wanted to know.
That's a very good question. I'm thinking to go a little bit deeper to answer that. So how does human brain learn? Human brain learns, a big part of it is language learning, and it also learns from observation, right? So language learning and observation are two big ways. And of course, there's genetic DNA that gets applied. So a university in London, a researcher, I forget his name, did a research on Sanskrit and yogis. And they found, very interestingly, and they took a control group of like 20 plus yogis who knew all the Veds and all the Purans and, everything in Sanskrit. And they would recite these complex millions of shlokas, like, very easily from their memory. And they did MRI brain scans, and they found their brain was 20% bigger than average. That learning expanded the brain. It is important because if you look at why humans are intelligent, one of the big reasons is brain size. And our skulls have evolved over the time, over like tens of thousands of years, of 50 or 100,000 years, to keep expanding to give brain more and more space. And it's spherical today. And that also gives it, the shape also gives it more space. So what happens is now it has kind of gone to at max what it can. So now how do you pack more neurons in that becomes a question. So they found from yogis, they had their brain, especially those parts which can remember and understand, were 20% bigger, and or denser, sorry. That's a big thing. Same thing happens with models. The large language models are effective. So when Google was researching and building that, there is something called parameters. When they increase the number of layers, initially the model was not that smart. Suddenly, at some point, like I think 100,000 or some number of layers and parameters, suddenly the model became very smart. They call it like learned habit. that suddenly develop. So size, as these models are growing, it's like human brains, they are becoming smarter and smarter. So there is something to be said on how knowledge, how reasoning, how capabilities evolve with language learning. Same with Sanskrit, because our brain is based on those small units that are actually built by all the information that comes in through the knowledge. So now these language models, with the number of parameters, billions and billions of parameters now they have learned the capability to reason out and the capability to adapt. So your question, when it goes to the model, if you ask a human, like if you ask Dr. Gopa or me to explain something, like I'm trying to tailor this presentation to non-technical audience. So if I had to present this to engineering organization, this would be different. So we all try to tailor our response to the audience, and model has learned that. So model did two things. First, it identified all the knowledge to answer your question, then it tailored the response similar to humans do. So models are very similar to how human brains work. They are not quite there, but the functioning of how neurons work, how layers work, how different architectures work is quite similar. And that's how it's able to tailor the response like humans do, because it has learned by learning the language. So, these models use a technique called generative AI, which means the only thing it does is generating the next word based on all the vocabulary that it has built. Now imagine how just the ability to predict the next word and learning the language has become an reasoning capability, right? That's how. So from language to, it's not designed, it's not trained to do reasoning. It is designed, it's called large language model. It is designed to understand language and generate the next word. And that has become a transformational capability in intelligence and reasoning, which appears to come out of it. It's not designed to become intelligent. There are different machine learning models that are supposed to be intelligent in certain application, but not large language models. So language to intelligence is a big transition that it has made like human brain does.
Okay. That's a interesting something food for thought. I mean, for a very long duration of time. And one of the participants are asking that since everything has a flip side, so how can we ensure that AI is used responsibly and ethically? I mean, this is something which we are talking in a very constructive way, but as correctly said, there are flip sides to the same also. So how we can ensure that?
Yeah, so maybe can we hold on to this question?
Yes.
Some of my presentation later talks about it, and then I'll stop in like maybe five or six slides.
Sure, sir.
Let's
Sure,
keep
sir.
going.
We'll continue the question answer session once, as you mentioned, sir.
Yeah, in like 5 or 10 minutes, maybe some
Sure,
of
sir.
these slides will cover it. So in
Sure, sir.
Meta, we use AI for content recommendation and feed ranking. So you always see feeds by more relevant feeds. So AI used there. Then generative AI tools these days, you see image, video creation, avatars, and stickers. Community moderation. I think, like you're saying, prevention of hate speech, spam, and harmful content is AI. And then the biggest thing is all the money comes from ads, and AI does ad targeting. So if you don't like an ad, it was probably not meant for you. It's not a bad ad because it is good for some people. Then YouTube has recommendations for videos, shorts, and live stream, which require it to know the context. So from video, it can learn what the video is about. Content moderation again, then AI tools like auto captioning, translation. For a long time, translation was a big application area for AI. Then summaries. And again, ads personalization and brand safety controls. Otherwise, nobody would do an ad if your ad shows up next to your competitor's video or something, or a bad video. Then Twitter or X uses content ranking and personalization of timelines. They also look at spam and bot detection. There's a lot of spam on Twitter. They use now generative AI assistants for summarizing long threads. Then AI powered ad targeting and engagement prediction. So often there is a trade-off between engagement and ads. So you show an ad and like results in Google, if people sometimes they go back from the page because they didn't like the ad. So ads tend to reduce engagement. So companies have to constantly evaluate trade-off between showing an ad and not showing an ad, including TV serials. If you have too many ads, you're not going to watch it. So they try to evaluate, predict the engagement, how much engagement is going to drop with a particular ad, and they factor in their modeling. Then, moderation of misinformation and harmful content, it's becoming harder and harder as they create these models. Users become smarter to beat them. Then LinkedIn is jobs and candidate matching using recommendation. Then AI writing assistants for profiles. Then spam and scam detection across messages. AI powered skill assessment and learning recommendation. Job matching is the biggest industry in the world. Almost, I think, 2 to 4% of global GDP is just about job matching. Then content ranking in feeds for professional engagement. So like you asked, risks, harm, and other things. So misinformation and deep fakes erodes credibility. So companies need to invest. If a lot of information on Twitter is just misinformation and deep fake, people are going to not trust it, right? So when you're using AI in your products, you have to make sure it is accurate enough, because AI is often not accurate. There's some degree of error. So what you have to do is take cost of error into account. Otherwise, you will lose credibility. Then over personalization is can be another problem, because like in Google they often debated, should we show results based on what your friends liked? But then they said, your needs could be very different. Let's just look at your searches and queries, and not just influence it by what your friends like, because you are different people. So whenever they tried to include social graphs into search, it never worked. So privacy leakage is another important area, and there are a lot of regulations especially in Europe and California. There are billions and billions of dollars of penalties that companies have to pay if they lose, if the data gets leaked out. Regulatory risk is always a challenge, in all countries. I think in India it is less if rigorously imposed right now than Europe and US. And continuing on that, so there is increasing regulatory scrutiny. So government also has departments that are actually with AI experts that are constantly looking in this. Transparency is a big part in some applications, especially I have seen in banking uh, and in Meta also, the area I'm working on, Instagram, screen safety. If we come up with a machine learning model to detect content is bad, we have to be able to explain to users. And first, we have to create a policy that's announced on the site, which clarifies to users why it is bad. We can just, so machine learning models can be black box. There are specific techniques to understand and create explainable aspects, but it's tricky. But so transparency is important, and you have to convert a black box machine learning model and explain it to users. And then you have internal guardrails like model audits. So for example, if something failed and it had a big impact on business, and it is AI generated output, then you have to be able to go back to see which and AI model with what parameters and other things caused the failures. So monitoring, and then sometimes you have to have quick incident response. For example, there was a murder in US recently of Charlie Kirk, a big famous political figure, and they don't allow the videos of his video of his shot was very fairly graphic. Those videos are not allowed on the website, but our algorithms failed to kind of control that, and there were a lot of escalations. So we had a red team incident response to tackle that. Um, yeah, so maybe I'll just take a pause and take questions for a few minutes here before I go forward.
Okay, sir. So there are a few more questions which I can see in the chat box. So first one is what challenges does Meta foresee in delivering a ultra low latency and high bandwidth for immersive AR/VR experiences?
That's a very good question. So number one is just a massive investment in infrastructure and data centers. So long time back, I mean, not long time back, maybe 15 years back when I worked at Google, Google was the only company that had transatlantic fiber cable that it had laid on its own. And it had created data center in Taiwan, which costed them $500 million at that time. So these companies are opening data centers as many as they can. and tier data centers, closer to users, which are small data centers, and then a little bit farther, full data centers. In the small data centers, they do edge caching. And in edge caching, they store all these heavy objects like videos and stuff. So from edge caching to building data centers globally, and laying down fiber optics and infrastructure, and especially in countries at one point, India is far more ahead than what it was 15 years back. Indian internet was very, very slow. ISPs were extremely slow, and they would sell networks to cost optimize. And sometimes you would get your data from, say, Singapore to go back to Europe, and then from there come to India, because that route was cheaper for them in terms of infrastructure available. But that added latency. Now it's much different. Now there are direct cables. Both government has created infrastructure, private companies that have created infrastructure that is sold, and companies like Meta are building their own, spending hundreds of billions of dollars. And now data centers, as you might know, are short of power and water. Those are the two things that data centers consume a lot to cool down. So they are building nuclear power plants on their own and not just relying on government to provide that power. So a lot of infrastructure investment is happening, uh, and that is going to lead to that is solving the issue that you're saying. But they are also looking at ROI. So areas where India has a lot of usage but little less monetization. So India has gotten less investment than maybe US and Europe or advanced economies, which have more money for them.
Okay, sir. As you mentioned, previous resource person was also talking about the investment on the infrastructure, and of course, that will have huge opportunities for all of us. So, one of the participant, they want to know that if one of the neuron in neural network makes a wrong decision, can the whole network give the correct output? That is in context of learnings which we just spoke about a few slides back, and in one of the questions which you answered. So if one that decision went wrong, or if that one learning went wrong, so will it have an impact on the overall setup?
So great question. So basically, one way these models work is what is called quorum. So there are always wrong outputs. There's never 100% correct output in all of the layers. So they have multiple branches. They have each branch doing its own analysis, and then they look at quorum to see which output has most voters. So that is one way, and there are many other ways where they filter out bad or error-prone responses in neurons. And ultimately, there is rarely an output that is 100% correct. So you will find data like 95% precision or 85% precision. And if your application cannot handle errors like recommendations, you won't like all the recommendations, but that's less error. Cost of error is low there. They see, okay, they get 10% users clicking on one recommendation, they have made their money. But if you're doing surgical operations, you want 100% accuracy. Then you have to have human in the middle, and you can only use AI for assistance because there always will be errors.
Yes, true that, sir. So one of the participants has asked that how can AI be leveraged to achieve the sustainable development goals similar to its application in optimizing urban planning?
Um, Sustainability is a good point. So today it is unsustainable mainly because of power use. So in US, what is happening is they have to bring back old coal power plants that they decommissioned because of the amount of power that is being used is grown tremendously. And if you look at global emissions, China is doing like 3 or 4 times the emissions of US today because of all the power consumption that it's doing. It's opening 2 new coal power plants every week. I don't know how to relate it to urban planning question. Yeah, self-driving cars. So one of the things about goals of self-driving car is to reduce traffic congestion, right? If you have self-driving car with your app that you can call anytime and go anywhere, with the high cost of insurance, high cost of everything, maybe toll roads and other things, you might just use a self-driven car instead of keeping a car, right? So that is one way AI can help improve urban planning. Then AI is also putting, say cameras which are automatically scanned for speeding and other things, right? And a lot of different applications are emerging in AI, which are actually also keeping cities safe and so on.
Okay. This one of the participants, they are asking that if is sir, with AI already handling content, ads, and moderation, do you think we are moving towards a fully AI-driven social platform, and how realistic is it in near future?
That's a very good question. Again, there's more and more AI being used. So in Google, for example, I think 60% of the code is now written by assisted by AI. And so in Meta, software engineering jobs are going to get hit first. They are creating AI and they are going to get disintermediated first. Fully driven AI-based social platform, um, some of them might exist already, right? I mean, people have single engineers or very small teams have created AI-driven, websites, or even say cooking discussions and community sites. But for a company like Meta and all, it will not become fully driven that fast. There's a lot of human judgment that gets involved. Often in teams, 70-80% time is spent by engineers in just ideation. Some of that cannot be done by AI yet. So
Okay, sir. I can see one of the questions. So, is there any evidence of cognitive degeneration using AI?
that's a very good question. Some research is being done. Yes, they are finding cognitive degeneration similar to, how calculators, when calculators came in, people's math became softer because, they stopped learning those type of tables and other things that they would learn in middle school, which is known to scientifically improve human cognition because of memorization of mathematical patterns and tables. Same thing is happening even more today as people are using AI to write code. They are becoming less effective in debugging the code. They are becoming kind of lazier, right? So that is definitely happening, but it's always happened. If you look at human brain evolution, I did a study at one point. Initially, from last 50,000 to last 2,000 years, a brain expanded. Then in last 2000 years, it has been shrinking a bit. So human intelligence, as previously measured, has been going down for last 2000 years, but its sensitivity is improving. Now humans are more sensitive to social aspect of things, cultural aspect of things, art, music, so some people argue that human intelligence has been shrinking for last 2000 years due to all this automation, but others argue it's shifting. It's not going down because now it's a lot more oriented towards social, cultural, and creative aspects.
True that, sir. And since you mentioned about culture, the next question is also a very interesting one. So, is artificial intelligence in near future going to assist doctors during surgical operations?
It's already doing that in some ways, right? Because AI can be behind all the graphs that they see, prediction. Cancer research studies, for example, they do that. So one person did a very interesting study in America. The doctors are very defensive because of all the regulations. So they studied a group of patients that were sent for advanced heart analysis, and they found that doctors are over sending people for testing by 40 to 50%. Anytime somebody complains of chest pain, often they are, if they have certain age, certain condition, they are sent for heart testing. But when they use machine AI to predict who should be sent for advanced testing, they found 50% more accuracy because AI was more objective. So a lot of people are recommending AIs for objectivity. Even say banks setting interest rate. Somebody did a study that if AI was setting the interest rate, economy would do better because humans get biased. Humans are more weighing towards short term than long term. So a lot of these things about human biases are taken. AI is even better, and that will show up in health care as well.
True, sir. I think the number of questions just got over, but we have one more question which popped up. So, what is the scope of AI in behavioral science and in which direction?
Uh, can you expand more? What do you mean by behavioral science here?
Can I request the participant to expand in which direction of behavioral science. In the meantime, there is one more question which is asking that will AI be useful in clearing lawsuits for those pending for years? And if yes, how?
It's a great question. I don't see it right now, but eventually, in fact, I was talking to my cousin who's a lawyer. These lawyers work very hard. I have a friend's relative here who's a district attorney in near my place, and she has to work like 16 hours a day because they have to look at all the case histories and search for finest points when they go for a case. So they charge a lot of money for a complex case because they have an army of people researching in previous decisions, laws, and their subtleties. So AI can really enhance extreme productivity there, on research, legal research, which is one reason why all these legal cases get blocked. Second, a lot of simple things AI can answer automatically. Like there is a legal chatbot I saw recently, where if you have a case, what will happen to my property settlement, you can answer it like you're talking to a lawyer, and they will respond and they will give you more, and then they'll ask you, "Oh, do you want to know about this more?" So even healthcare and legal cases may move to some of the automated self-learning process. I mean, if you know what your result is going to be of your legal suit sometimes, and you know it with confidence, your lawyer might be biasing you, but why would you spend money to file a lawsuit if you know you're not going to win?
That's true, and of course, this has a lot of you. Since you mentioned it, and the question was being asked, this has a. Uh, somebody has mentioned that in heard that in China they are using one AI as judge. So is it true?
I don't know.
Okay. Okay, sir. So the participant for the behavioral science, she mentioned that when you talk about, I'll repeat the question again, just 1 second. So, what is the scope of AI in behavioral science and in which direction? So, by behavioral science, she wanted to ask in terms of predicting behavior of humans in organization, because a lot of data or a lot of prompts are going. So, of course, is there any future of predicting such future in the
So in some
organization?
ways, what we do is Meta is predicting user behavior, right?
Mhm.
Um, yeah, one of the things in organization in Workday, what people do is predicting attrition. So they try to see they have a predictive model where they say, this is the probability of a person to leave, promotion delayed or experience levels, skills not utilized, and they are compensation, and they try to give strategies, and HR comes up with strategies to improve retention. And then employee engagement by looking at interactions and things like that are some of the things that organizations are using AI for. And for consumers, Meta, that's what Meta does, right? It predicts user behavior through content management and recommendations.
Okay. So we have one more question. Okay, just there are so many questions which popped up. Okay, so they have mentioned thank you. I think I'm able to cover most of the questions. Yes, there is
Okay,
one
I
more
think we are
question.
running out of time, so I can share the
Yes, sir.
slides. But
Yes.
basically, quickly going through it, future trend, multimodal and real-time AR/VR is one area, where it is. So we are looking at in Meta immersive social engagement through glasses and other things. Ethics and responsible AI with stronger safeguard is a big, big area. Then social commerce and all. On device and decentralized modeling is another aspect. On device, like iPhone is now carrying large language models that can do analysis right there without privacy worries. What I recommend as you're building AI is start with high ROI cases, something that has worked, because AI can be very fancy, but it is also can be costly. So identifying high value cases is important. Thinking about safety from the early days, like auditing and human review, is extremely important. Then it has to be measured. What matrix are you trying to improve with your using AI? then modular infrastructure is important based on the scale you want to get to, because it's going to scale. So start thinking of a lot of these services are provided as cloud services now. um, so have KPIs and evaluation framework, engagement lift, ROAS, then false positive and negative rates, appeals, trust and retention. And then think about risk mitigation. So in social platforms, AI is central. It has a large market opportunity, but forecasts diverge a bit and big range. Then, safety, transparent people who are thinking about safety, transparency, creator economics will be the winners. So we've run out of time. If there is anything, Dr. Gopa, you want me to answer?
Yes, sir. So there is one question which one of the faculties has asked, that since we plan assessment for our students as a faculty, so they are using AI too much. I mean, they basically stop thinking about the answers and ultimately submitting us AI generated assignments. So please advise on that.
That's a big thing. Somebody, one student was bragging about it. They graduated from UCLA, a big university in US, purely using ChatGPT. That's a real problem. I don't think I have a good answer for that. One of the things is you have to come up with different test patterns. Maybe, verbal discussions and other things. So, you guys are educationists. You have to think about what alternate methods we can use without AI tricking us, like when there were calculators, people were not allowed to take calculators in the exam rooms. So, educationists have to figure out ways where people can be tested for knowledge. Some of it, maybe patterns will change, like if people can use calculators, maybe get softer on certain aspect of math. Or similarly, if certain things can be done by AI, you move your education pattern to more value added stuff of which can't be done by AI.
Okay, sir. So this is the one of the question, I don't know, I have received on my WhatsApp chat. So they're asking that will AI be able to predict the emotions also, like they're able to predict the answers? So in future, maybe our
So
moods.
there are two different parts to this question. One is actually if you read ChatGPT and you ask it to tone your response in certain way, exuberance or more objective narrative and different type of emotional patterns. It does that already. Um, what it does not do is sensory. It can sense your emotion. So if you're writing a question, unless you tell it explicitly, it won't know what your emotional state might be, or it might be able to gauge from your text, but it lacks the ability to sense and feel like humans do, empathy. But so that's multisensory aspects, and there is actual research happening. They built a robot which can actually sense objects around it. There's also research on 3D, multidimensional information gathering through senses in robots. So that part of emotions is being researched, but the part of emotions where AI can understand what emotional response are you asking for, or what your emotions might be in the text you have input, that's already there.
Okay, noted, sir. I think I'm able to cover most of the questions. If any participants they have any questions, otherwise I'll forward it over to you, Gopa.
While you were taking the questions from various participants, Pritha, I received personal DMs because of certain technical issues that they were facing. So the question that has been asked is, how do you see generative AI reshaping content creation and community building on social networks, especially that you mentioned that you're working for Instagram users. So this question is centered towards it.
Sorry, yeah, my network broke off a bit. Can you please repeat the question, Dr. Gopa?
Sure, sir. So how do you see generative AI reshaping content creation and community building on social networks?
Yeah, it's a very, very big area. And if you've heard Mark Zuckerberg, he wants to build super intelligence. There's a huge amount of investment that is being made. Generative content, like all of these services now, you can go in if you're writing a post, it will give you hints on, can I write it for you? And it will phrase it for you. It'll also grammatically correct the content that you might have created. It's happening everywhere, not just in Meta, but in Google Docs. You can use Gemini AI to write the Google Doc, and in Twitter, you can use it X to write posts. So a lot of content and creative, in India, I don't think they've launched it, but in WhatsApp, you can generate images, and emojis. That was even earlier, but you can say, imagine me like this, and it'll create your photo, try to create your image based on the ask in that environment, in that context. I did it for my parents, like my dad. Imagine my dad sitting next to Mr. Modi, and it actually created the post. And my dad was like, "Wow, how did you create it?" So a lot of these things are happening. There's a lot of investment. The only thing is it takes a lot of compute power to generate these images, and that's what they are trying to scale very quickly. Now, India has so much usage that they have not launched some of these features in India, but in US and Europe, there are a lot more features.
True that, sir. So, the next question which has been asked is, do you think users are aware enough of the invisible role that AI is playing in shaping their online behavior? And if it is not, what should the platforms do?
That's a great question. Obviously, not everybody knows how their data is being collected. So almost all the websites have fine prints, terms and conditions. If you go through all of that, they kind of try to disclose how their data is being used and how AI is being used. Some of it is hidden behind the scene, and it's not harmful, right? It is used for good. So governments look into things which may be used for harm, like their privacy laws and all that. So a lot of it falls on government, and government requires transparency and disclosure where necessary, and companies have to declare it. Otherwise, pay huge billions of dollars in penalties. So that is one way. The other thing is they are looking to provide more transparency to get users. If users are afraid that their data might be misused, or there may be AI lurking behind it, then they won't use it. So that's where I said explainability is important. Like in my world as well, where we try to detect harmful content for teens. Ultimately, before we can take any action, we have to declare it to the users and incorporate in the policy that's announced on the site.
Thank you for that prompt answer, sir. There's a very interesting question which has come up, and it mentions that how do you see AI enabling accessibility and inclusivity? For example, supporting differently abled users on social platforms.
That's a great question again. So different countries, places have different laws. Like Europe, accessibility laws are very big. In California as well. Most of the accessibility laws are around font sizes and how text is written maybe from left to right and other things which people are really need, or convert text to voice. So AI is really helping with that. Text to voice is an example where some users who have a hard time reading, or even if they're, I mean, say color blind, they can be told by voice what color image is, right? So AI is really helping making the content easier for accessibility. And what was the other thing you were asking? Second part, adaptability.
Yes. So
Yeah, so
accessibility and
personalization, right?
inclusivity.
Inclusivity. Um, I'm not sure if I can connect to that. Um, Generally, inclusivity is an important part of building any service, right? We want everybody who can use the service be able to use, right? So whenever they do AI, they tend to make sure it's not biased. It's not, but they have to balance it with personalization. So personalization also kind of helps with adaptability, where you don't have to worry about showing one content to everybody, which may turn off certain type of users. So you can really tailor the content for the type of users. So that improves inclusivity.
All right, thank you, sir. Can you ponder your thoughts on the focus on the latest news about Honorable Vishwas Nagre Patil, ADG, and the 78 lakh fraud using AI?
I don't know about this specific case, but there's a lot of
I
fraud
think this is
happening
a
due to.
spam. I think this is a spam. I'll request you to continue.
Okay.
So
So
there is a lot of fraud that is happening with AI, deep fake and others. It is risky. So, but that's happening with internet. So keep your bank account safe. Sometimes I've had a case where, I got spammed. So, yeah, AI is being used for fraud and spam. In significant case, it's a big risk. So everybody should think about, keeping their data and money safe.
all right, so I think there's one more question there, and it mentions how does Meta ensure data privacy and security while optimizing network operations for billion of users?
So yeah, encryption is a big way. There are encryption technologies are being researched and improved, every day. It's harder and harder to break and get visibility into users' data through hacking networks. Even if you are on unsecured Wi-Fi, you would not be able to easily uh, interpret the packets that are sent over the network in especially in Meta's case.
Okay. So there's some question over here that talks about beyond content recommendations and targeted advertising. What are some emerging AI-driven use cases in social networks that are significant according to you?
So uh, immersive experience is a very big thing. So, Mark Zuckerberg is investing a lot in, the headset and the glasses for immersive experience. If you use Meta glasses, you would know right now they don't have that many applications, but the fact that they can get all the video screen information and all that is designed for immersive experience. Even in some of the cars, you can see now it projects the dashboard as a screen on the windshield. So you feel like you are reading while driving. You don't have to move your eyes around. So immersive experience is a big area social networks are investing in. Again, compute and algorithms are both extremely important. So they are optimizing algorithm more and more so it can run on less hardware, while hardware is improving a lot as well. So I would say that's a big area of investment. And then content generation, generate images. People want to generate pictures in different context. That's a big one.
All right. The same participant has firstly thanked you, and then he's asking his last question. Could edge computing and AI driven network management meet the QoS needs of large scale metaverse adoption?
Of course, network management is AI driven. Edge computing, like I said, satellite data centers, they are creating Akamai and other edge caching networks are investing a lot. Edge computing is a very big deal. The amount of money that Meta and Google spend on network infrastructure is like huge, hundreds of billions of dollars. So any small optimization saves like billions and also improves experience, right?
Mhm.
So yeah, um, all of these are active areas of investment and work.
All right. So there's another question which talks about how is AI being used to detect and curb misinformation, hate speech, or harmful content, and what limitation do we still face?
That's a great question. So I'm directly working in the space in Instagram, right? So AI is first of all helping in detecting these content by learning patterns. And so earlier what we used to do was we had defined a list of words that suggested there is some hate content, like fight, war, violence, kill, or ugly, or racial slurs, black, white, brown. So those type of things, we had list of words that we would use to scan messages. Now we use AI, which can also look at context, like black, you could have black ink or something else, or fight. You're talking about a boxing match with your friend. That's not spam. So now we look at context and we look at other semantic similar words. So our algorithm, our ability to detect scam or hate content has become much smarter with AI. We have more confidence output. So we have less human workload on review, so we can scale more. AI is being turning out to be very effective in detecting these type of content. The challenge is in creating policies. So when you have AI, you create a black box model. So suppose you want to ban any post containing the word fight or kill, suppose you want to ban it, you can explain it to users that that's why you banned them. But if you are using a black box model and you suddenly block somebody, and they don't know what the policy if they violated, that becomes a issue, and then they appeal sometimes, and then appeal load increases, workload increases. So explainability and defensibility are two challenges with AI model based some of these detection.
All right. So the list of questions are too many. I'll just try to cover as much as possible. What role does generative AI play in Meta's long-term vision and social media and wearable devices like Meta Ray-Ban glasses? And what's upcoming technology?
So yeah, generative AI, first of all, mostly it is used in web apps, image, text, and videos, right? And in a safe and effective way. Because suppose Meta does a poor job in generating an image, then user will try again and again and again, and that will use a lot of compute. So making it more precise and effective in generating content that makes people happy. It's also an area of competition. If Gemini or some other app is building better pictures, users will go there. So making it more smarter in understanding user needs, creating better pictures, better video is an active area of research. Models are improving every day. In fact, Meta may not be as ahead as OpenAI or Google Gemini today. That's one challenge. That's why they are trying to hire people from there. So making those models effective. Ray-Ban and other things, I'm not that close to that virtual reality area, so I can't answer that well. But suppose you are using Ray-Ban, their Meta glasses, and you find a speeding car. You want to note its license plate number. And I want to ask Meta glasses to give its license plate number, or just save it, or call police with the license plate number. It can't do that today because it's moving so fast. It doesn't have the ability to read license plate numbers even in stationary cars. So those type of abilities to detect and interpret video content is still very primitive. That's an area of work.
All right. So I couldn't resist but to ask you this question. Could you share some examples of how AI has been used behind the scenes that most users might not even be aware of?
Uh, I don't know if you know how much Google uses AI behind the scenes for ranking, so it depends on people, who are closer to the problem and broader audiences. AI is pretty much used everywhere in different shapes and forms. That's all pretty much I can say. It's called AI everywhere. So it's just everywhere. It's not necessarily harmful, but it is used because it's helping. It can have harms. Big companies avoid that, but there's always risk.
True that, sir. I think the question list is not ending, but then we will conclude over here. And thank you so much, sir, for such a thought-provoking sessions that you held today, and your discussions on how AI is transforming communication networks through intelligent automation, predictive analytics, and generative AI application has really expanded our horizons. So, the way you connected AI with the real world challenges like network optimization, user safety, and scalable infrastructure was truly inspiring. And I'm very sure that the participants will especially benefit from your examples on how AI is already shaping the future of communication platforms globally. So, the wealth of brilliant cases and example that you shared today, from the recent Charlie Kirk case to Quorum and many such others, have really added immense depth to our learning today. And, sir, thank you so much for addressing all the questions with such patience and clarity. And on behalf of the Institute and all the attendees, we sincerely thank our overseas speaker for joining us despite the time difference. While it's late evening here in India, it is pretty early hours of the morning in Pleasanton, California. And thank you so much, sir. Your efforts and insights on AI powered communication are truly appreciated. Thanks a ton. And thank you so much for being with us today.
Thank you so much for this opportunity. I really enjoyed the session. I love talking about this topic. I wish I have more time. I can answer any questions. I can stay back. But thank you for the interactive session. Thanks for the opportunity and the kind words, Dr. Gopa. I have really enjoyed this. Thank you again. It's been fun talking to you and talking to the audience. Thank you.
Thank you so much, sir. The pleasure is all ours, and we have really enjoyed the live examples that you have quoted today. So, with this, dear participants, we come to the end of day one of the FDP. Today, we had a powerful start of the FDP with insightful sessions on 5G and 6G technologies and AI and communication network. And I really thank our distinguished speakers for setting the tone so beautifully. Before we close, may I now request all the participants to kindly share your day one feedback through the link that has been provided, and your inputs will help us to enrich the sessions further. So, requesting the co coordinator to do the needful.
I have shared one link in the chat box, so participants can they share their feedback. Uh, while participants fill up the feedback, I wanted to share that tomorrow we have a session. Tomorrow the sessions are scheduled from 6 p.m. till 9 p.m. and we have two sessions. So the first session is on the topic on IoT applications in business and by Mr. Dushyant Arora. And the second session, which will start at 7:30 p.m., which will be on the topic role of cloud computing in modern communication, will start at 7:30 p.m. The link for tomorrow's session will be shared with you on the WhatsApp group, and I think all the participants they must have received the link. So tomorrow morning, for I'll share the link for tomorrow's session. So in the meantime, I'll request you all to please share your feedback. Yes, I'll share as mentioned, I'll share the feedback link on the WhatsApp group. So this is a day-wise feedback, and overall feedback will be taken at the end of the seventh day. I mean, at the end of the completion of all the sessions that will be conducted on the ATAL website. So I'll just share the feedback link on the WhatsApp chat group. So I've shared the Google form.
Dear participant, kindly note that all the links will be shared day wise. So, dear participants, it's 9:30 now. We will take a call off from today's FDP session. Thank you so much for joining us, and thank you so much for all your support and being a patient listener. So, see you all tomorrow. Thank you so much for joining, and have a great learning ahead. Good night and take care.